This meeting is being recorded.
Good evening, folks. This is the February 22nd, 2024 meeting of the St. Louis Linux Users Group. This is Lee. I'm helping out here. Gary's still on the way. James is not here, and Stan's microphone isn't working. So I am going to start the meeting. Who is that?
This is Stan. Can you hear me?
Yeah, Stan.
I had to change headsets.
You want to do your opening spiel? I just started the recording. Are you going to be bashful tonight? Should we go ahead and start the meeting? Stan, is your speaker working? You hear me?
It's
okay.
Something else died on me.
Oh. Well, since Alex is ready to jump into it, why don't we just go ahead and start the meeting?
Sure. I guess I'll share my screen then.
At least let me introduce you.
Yeah. Go ahead.
We have a very special presentation tonight. We got anonymous tip here a couple months ago that there was a fanatic about large language models right here in the area, chap by the name of Alex Towell, and he agreed to do a presentation this month. The actual topic is demystifying large language models on Linux from theory to application. Alex, over to you.
Thank you. As he said, my name is Alex. I have a master's in computer science and mathematics, both from SIUE. You can reach me at Lex. Wait, can you see my screen?
Not yet.
Okay, I'm gonna do it. How about now?
There you go.
Okay.
You got it.
You can reach me at lexmetafunctor.com. My blog's here, metafunctor.com. I have a GitHub at Aquilius, Twitter, and you can actually see the all the material for this presentation at this GitHub. Let me maximize this. Okay. And yeah, I'll be presenting large language models and also just this new age of AI. And here's the outline. I'm going to go over basic theory. Then I'm going to go over a very simple, probably oversimplified language model. It's called the in-ground model. I have a Jupyter notebook for that, and you can, if you want, play along with me. And I think maybe it'll help us understand certain things about these things if you can get your head around this simple language model. It's not very good, but it's interesting, I think. And then I'll show an application of an LLM. I try to make, I make a database search API intelligent. I give it natural language understanding by just using LLMs to try to take in the data, process it, and figure out what the user wants and return the right kind of data. It works okay on the small models, but really right now you need like the large GPT-4 level models or even 3.5 for that to really shine. So we're not quite there yet, but it's getting there. And there's also various techniques that I can quickly discuss that will probably help it too. So then finally we'll end with an open discussion. So, you know, in the early days, like Alan Turing, all those founding fathers of computer science, they did quite a lot of research into AI. They were pretty optimistic too. You know, there was one guy, I can't remember his name, but he had this idea that he could get together a bunch of smart people and knock out the whole AI problem over a summer, or at least make large progress on it. Turns out that it's a lot harder than we thought. So, you know, the first age, the good old-fashioned AI, is, you know, in that case, we try to symbolically represent the problem and then use logic or rules to solve it. You know, these rules are things we can understand with our small little brains. You know, this is programming, rule-based systems, first order logic. well, my favorite programming language is still probably Prolog, but that's a pretty obscure language, although I think it may make a comeback. I don't know. Because all these things, the good old-fashioned AI, I don't think it's going away. I think, in fact, they could see a resurgence because these LLM models are pretty good at tool use. They're good at language, language understanding. They've seen plenty of training data about how to use these tools and everything else. So I think that may be an interesting outcome of all this. So good old-fashioned AI, it works for a lot of problems. You know, programming on the whole is based on just taking the problem, you know, filtering it through our small working memory, and then breaking it down into smaller problems that our brain can understand. We keep doing this until the problem's small enough that we can solve those, and then we combine those solutions in some way to solve the big problem. You know, our small working memory is kind of what we call an inductive bias. It makes certain assumptions about the world. And in our case, in our universe, those assumptions seem to help us reason about the world, to generalize outer distribution. Like we can see we can make new observations and still be able to come to reasonable conclusions, even though we've never seen that situation before. Our universe just so happens to work on some of these simple rules like physics and things like that. That kind of inductive bias works, but not always. Many problems are hard to break down into simpler parts. You know, that whole expression, the whole is greater than the sum of its parts. This is also thought about as maybe emergent phenomenon, you know, things we can't quite grok, maybe even consciousness, just something that we can't understand because it's just too complicated and it can't be easily reduced to a simpler system. So some problems are just too complex to solve reductively. And if that's the case, then we can't program computers to do it. We can't even identify cats in the picture very well. Now, I think Steven Pinker said the hard problems are easy and the easy problems are hard. And by that, he meant that the things that we consider to be like higher level problems that really take a high IQ and all that, you know, those things are easy for computers to do for the most part, like differential equations and linear algebra. All those things in chess, they can do those problems pretty easy. But the easy problems, like playing with Legos or, you know, or identifying cats in a picture, that's hard. So how do our brains do this? Well, our brains are programmed by evolution to survive in a very complex world, and it's been going through this process for billions of years. You know, our brains are still more massive than, you know, GPT-4 level models. You know, our brains are a very capable prediction engine. It learns to predict the world. It learns to predict its future observations. But the conscious mind, the unconscious mind, is not limited by a small working memory. It can do things we can't understand. And because of that, the brain is a black box. That's a big area of research right now in interpretable machine learning and the alignment problem and all that. I'm not going to go into that too much. We can talk about it later on if you want at the end, but I don't have a lot to say about that right now. So if we can't solve it reductively or using our conscious mind to try to reduce these hard problems to simpler problems, let's have computers learn from data the same way we learn from experience. And there are three main types of learning. There's supervised learning, unsupervised learning, and reinforcement learning. LLMs use a kind of self-supervised learning and RL, HF, but RL in general, reinforcement learning in general, will be possible, especially on synthetic data and things like that. And we'll get more into that later, but supervised learning is kind of an interesting middle ground. So it's almost like supervised learning, ultimately it learns an unsupervised problem, and it models the data generating process of whatever data we're looking at. That's unsupervised. So supervised learning, is this learning from labeled data. We have some input and output data, and we want to learn how to map the input to the output. Maybe a bit technical with the cats and dogs, but I don't know. But given an unknown function f and a set of input-output pairs denoted by x, comma f of x, learn to approximate that function, f hat, on those input-output pairs. Classification, for instance, we have some unknown function f, and it takes a cat or a dog, and maybe images or whatever, and it identifies that as either a cat or a dog. So if we can estimate that function well enough, then we can use that to predict, is it a cat or is it a dog? This is probably the easiest problem to solve in machine learning, but it's very limited by data. When we fine-tune LLMs, this is a kind of supervised learning approach. We're fine-tuning it on labeled data, essentially. It's not exactly in the same sense labeled, but we're trying to improve it on certain kinds of tasks. And of course, it's kind of interesting that like GPT-4 level models, they can actually generate this kind of data for us, like synthetic data. It's been shown that a lot of small models are just trained on data from like GPT-4 level models. There's also other ways to train it to more efficiently replicate the behavior of these large models. It's called like distillation and things like that. I won't go into that right now, but there's a lot of research. If you look at ArcSiv preprint, there's too many papers to keep up. The next type of learning is unsupervised learning, no labeled data. We're trying to learn something about the underlying structure of the data. Classic example is clustering. We take a bunch of data points in some higher dimensional space or whatever. We try to group them in various ways, and all kinds of different clustering algorithms. And it's interesting though that like RAG, Retrieval-Augmented Generation, uses clustering to it will use the representations learned by these large language models. It'll cluster them. Then when it sees like new data, it can say, what is this new data most like? Then it can look in that database, find the nearest examples or exemplars. Then it can find out, okay, what data does that map to? It's a much more context, semantically aware kind of way of doing these database lookups.
Alex, what's RAG an acronym for?
Retrieval-Augmented Generation. It's all the rage right now, I guess. It hasn't quite worked out as well as people hoped, but it's still a work in progress. And there are very interesting examples of it. But yeah, the idea is that you take the high level idea is that you just put a bunch of data into context of the language model that's relevant to that context, so that maybe you have some like math question, and you want to add a bunch of facts about math or ways of solving math problems that might help the language model solve that. It's like chain of thought prompting, where you do this step-by-step reasoning, and there's all kinds of things like that. Other kind of unsupervised learning is dimensionality reduction, and that's about learning efficient representations of the data. This is a very hard one, and one of the most important problems in machine learning. We'll talk more about that later. Density estimation. This is just a stochastic estimate of the process that made or generated the data we're observing. Say the process generates pairs X and Y, and we estimate its density with this probability function. That's the PR stands for probability, and then we're just taking the probability of X and Y as a joint distribution over X and Y. And classification is just a special case of this larger technique. Where's my? This is the most general form of machine learning. If you learn this, in some sense, you learned all there is to know about the data. Of course, you can't learn all there is to know about the data because that problem's intractable. But you can learn a lot about it. And when you do, all the other kinds of techniques reduce to just different variations of using this probability joint distribution to do things like to compute new kinds of tasks. Classification, a supervised learning approach, is just a conditional distribution of Y given X. And that's not easy, but it's proportional to this joint distribution. So if you know that, then you can answer that kind of task as a special case of this larger model. The pre-training stage of LLMs is like unsupervised learning. You learn the distribution of the raw text, whatever, all the crazy text out there on the web, and a lot of this very toxic and so on. But you learn that raw distribution and use that using self-supervised learning. We'll talk more about that later. But basically, is this saying, given this context, given all the tokens or words that came before, predict the next token or the next word. And that's actually a very powerful way of doing this. The final type of machine learning is reinforcement learning. This is an agentic approach. So conceptually, an agent, interacts with the environment and also can take in perceptions from the environment, has sensors, whether virtual sensors or other kinds of sensors, like a physical robot has cameras or whatever, takes in the environment and learns from just a simple reward signal. And the goal in this case is to maximize the expected sum of rewards. Right now, there are a lot of agentic frameworks that try to include large language models as a prediction component, as a important piece of that framework. And we can kind of see that if you can predict and you can do some kind of search procedure over possible futures, counterfactual reasoning, then you can do planning, like long-term planning. That's still very much a work in progress, but that's what kind of everyone's moving towards, finding ways to unlock that. We're not there yet. Maybe we'll have to change architectures. My guess is scaling up will enable a lot of these capabilities, but you probably will have to run it in a loop. Like say, okay, have you heard of the tree of thoughts approach, where you just you prompt the model to various ways to generate different possibilities, and then you evaluate those possibilities in some way, which may just be prompting the model again to select branches to explore further. And then you can kind of have it explore a tree of thoughts. And it hasn't panned out too well yet, but that's kind of the idea, combining prediction plus search to enable like system 2 thinking. Right now, in some sense, these large language models have system 1 thinking. They're very intuition driven. They're immediate. They look at the context and come up with a very quick output. Now, whether you're thinking about the Raymond hypothesis or about what to eat for lunch, it doesn't matter. Of course, there are ways to get these things to think longer about it through like chain of thought prompting and tree of thoughts and whatever else. So, I mean, this is actually a big reason why people are so excited about Sora. Has everyone seen Sora yet? I mean, let me open up.
Scott had given us a little hint, a little taste of that last week.
Oh yeah. This is it's pretty incredible. I'm on Twitter, so if anything pops up crazy, it's not my fault. But
Yeah.
look at this one. Oh, all right. One second, go back.
Yeah, generated AI.
Yeah.
Wow.
Yeah, you just tell it to it's two pirate ships. I can't remember the prompt, but two pirate ships battling and a coffee cup. You know, and there's so much more of this. This is not even the most impressive one. It's able to do this kind of generative AI. You know, like I thought this was going to be like a year down the line at least, but OpenAI comes out and releases this. Not releases it, but they show it. It'll probably be a while before we get access to it, because you can imagine this could be all kinds of safety training for this, like red teaming and all that, just to make sure it's safe. Because the election's coming up, it's going to be crazy. All the it's going to be hard to tell reality from fiction.
Oh no, nobody would try and screw with the election. Never mind.
No. Let's hope you're right, but let's look at a couple more, because if you haven't seen it yet, I mean, you can't. I used to get more videos, and all of a sudden, let's go to YouTube maybe.
They had that one with the girl on the street on
Oh, yeah.
GMA, and they show that the right leg turns into the left leg.
Oh yeah, all kinds of there's all kinds of things like that happen. You know, it gets little things wrong, but it often gets a lot of things wrong. It takes a while to notice.
Yeah, the one with the I think it was an older woman, an older lady. She was kind of mixing a bowl, and like the spoon or the fork comes in and out, and
Yeah.
the smile. It was pretty creepy.
Yeah, often it can be kind of creepy, because it's I don't know, it's like doing things that you can't really tell at first blush, but then you get looking closer and you notice more and more anomalies. It's weird.
Yeah.
But I mean, it's able to do this. You know, it had to learn quite a bit about about reality, about the world, to be able to do this kind of stuff. You know, you can't just generate raw pixels without also having at this level, without also having some representation of the world, some model of the world. This is weird. But there has to be something, you would think, that's going on where it's able to kind of reason about the world, understands things about it.
Can you stop hovering over the thumbnail? Maybe that might boost the speed to
Okay.
everything.
Sorry about that.
Are any of these bitmapped, or are they just pure images? Because I've seen for a while there people doing Blender generation, not completely through, but some assets and things, where they'll do like the movement part, or I just wonder if these are pure video, if there's any actual asset generation manipulation going on.
No, they claimed that it's just pure video, just text prompt to video, or they also can do images. Like they can actually give it an image and say, okay, imagine some world where this image is the final one. So it can do all these weird things like that, and it kind of has what you might think of as a intuitive physics engine. Like within the weights of that neural network, it's modeled something like a physics engine, kind of like a world model. And maybe in the future, you can use this capability to have an AGI or an intelligent system think about the future, think about future possibilities and plan in a very complicated environment. Because language is nice, but it's not nearly as complex as reality. Language is by design very information rich, very low noise. Most of language is just very high signal, very low dimensional, but it encapsulates all the things we care about and think about. So it's still important, but it doesn't require as much representation learning as Sora represents. So that's kind of a new capability that has got people wondering. I'm gonna go ahead and close this down. Okay, where was I? Okay, we kind of went off on another tangent, but I'm going to go back to talking about the history of machine learning and what led us up to where we're at. There were early failures in machine learning because reality is just very complicated. The number of the sequence length, how many things that we have to consider at once, the dimensionality of each object that we're looking at, all that is extremely complicated. And early efforts were not very successful. They just weren't large enough. They didn't have enough data. Not enough compute. This didn't work out. Its time wasn't yet. A lot of the recent progress isn't based on new insights. A lot of it is just based off scaling up things, just making the systems larger, making the data more intensive, and that seems to work. It was actually Richard Sutton, he wrote, like, the founding father of reinforcement learning. He wrote the book. He talked about this, he said the big lesson is that general methods that leverage computation are ultimately the most effective. So in the early days, we had all kinds of very advanced, clever systems, clever machine learning models, like support vector machines and all that. And they were all the rage for a time because they were able to do a lot with their very limited training data and very limited computation. But they didn't scale up. Once we got more data, more computation, they just couldn't compete with neural networks. So neural networks came back on the scene, and now, of course, they dominate everything.
Back on that slide, please.
Oh, sure.
So the term overfitting in this case, well, how would you define overfitting?
Okay. So like, let me draw something. I'll just do a simple example. Say you have say you make some observations. Let's say we have this. Let's say we make some observations, from something. You see that dot, you see that dot, and we see that dot. Now, maybe this one too. Now the best fit to the training data might be something like this. Let's suppose then that we see a lot more data. Like this one goes off like this one goes off like this because it's a polynomial, and the end just go off to infinity. All of a sudden, you see this. So we trained on the training data. That's what we saw, and then we wanted to use that data to make predictions about the future. Well, here's the future, these points, and this thing doesn't say anything about those points. The best line, if you see it, is probably like this. And then, of course, this line maybe like y equals like 1.1x plus some noise, where like often noise is like Gaussian. Like they'll do something like that, whatever. But this straight line helps you fit the data, the future data, much better. This line is just it's overfit to the training data. Yeah, it's a well-known problem in machine learning and statistics. We do a lot of things to combat that. You know, there are things you can do. You know, you can only use some of the data, hold out some for verification or testing. So, okay, I'm going to fit it and see how it does. Then you can kind of tweak the hyperparameters to do something a little more clever. But it's a problem, and there's also what you call a bias variance trade-off. The more complicated the model, the less bias you have, because we have this and this, but the more variance you have, because it's much more sensitive to training data. Because this thing right here, if you had, instead of seeing, like, say you see this, it's okay like this, right? But then all of a sudden you see this point. You see a new point. So okay, here's what it is. So one point added to it completely changes the shape of that function. So there's all these trade-offs in stats and machine learning, and it's interesting that these large language models and large neural networks, they have more parameters than they have observations, and they have trillions of observations. Not, well, I guess not more parameters, but they have way more parameters than you think they would need. And there's many theories about what's happening there, because it seems to violate classical stats. We had all this theory about how much data you need, how much when you will just be too complicated and overfit to the data. And then all of a sudden we have these billions of parameter models, and they're doing better than ever. And it just so happens that one way to make the model simple is to reduce the number of parameters. Another way is to apply some procedure that penalizes complication, like stochastic gradient descent. It's very stochastic, and it operates on batches of data. So as you get more data, as you get a new batch, it will randomize things, and it can never fit too much to the data, because it's always seeing different subsets of it. But there's other things you can do too. It's like, you can try to impose sparsity, and of course the many layers of the neural networks, and these deep learning neural networks. They have these inductive biases where one layer learns some representation, another layer learns another one. They kind of learn these circuit programs, and not fitting the data, but they kind of learn circuit programs that generate the data. But all this, there's still very much unknown. A lot of times we're just kind of doing things, doing experiments and just kind of engineering things, and there's no formal theory for all this yet. Maybe one day we'll have it. Maybe a future AI system can help us develop it.
For sure. It's almost like the point there is anytime you have the y-axis, whether it's time or some measurement or whatever, but once you go beyond the bounds of where you've actually collected data, boy, it gets more and more that predictive curve there.
Yeah, this whole thing out here, like you make a good point. All this like here for this model is, it's good at stuff within its training data, and it can also do pretty good at stuff that's within its window, kind of like interpolation, besides rather than extrapolation. Like you said, once it goes outside the bounds of it, they can often be pretty good at interpolating between values. But yeah, once you go off the bounds, though, things can just go off tracks quickly. And
the cursive dimensionality, is that a related concept, or?
Oh, that's this how when you increase the number of parameters or like in the language model, if you have let's see, you have this to learn a function that has like in like a vector of size n, the number of possibilities, like let's say we have zeros and ones. Each xj is just a 0 and 1.
Mhm.
Right? And let's say so we're just learning a bit sequence. How many functions does that represent? Because when we're doing machine learning, we're trying to learn the function that generates that data. Let's say there's no noise or anything else. It's just it's an exact function, and we want to figure out what it is. Now, if you don't see all of it, that's even more problematic. But let's say you see all of it. There are 2 to the 2n functions. Just on this, let's say, oh yeah, also not just that, but it takes a, and we're asking, okay, what's x of n given this? That might be the function. And in this case, x of n is also binary. And when that's the case, then we have this many possible functions. I have one that, but like you can do a simple table like an and table, right? Like, well, say you have a
Red light.
x1, x2, right? How many functions are there for this? Well, and will take 0, 0, 0, and it'll take 0, 1, 0, 1, 0, 1, 0, 1, 1, 1. That's just a basic logical and. But there's other ones too, right? So this thing right here could have been 0 or 1. So there's 2 possibilities there for any chosen function. 2 there, 2 there, 2 there. When you multiply these together, you get 2 to the 4 or 16. There are 16 possible binary functions. And is 1, there's or, there's XOR, and so on.
Mhm.
Now, of course, the course of dimensionality just means if you add another one, now all of a sudden, instead of 2 to the 4, we have 2 to the 2 to the 5. 2 to the 5 is, wait, no, 3. So 2 to, we have 3, and then it's 2 to the 3. That's 8. We have 2 to 8. Now it's 256. So it's exploding. It's exponential growth, right?
Okay.
And this is the simplest case you can imagine. Just a simple binary function. Reality, of course, is much more complicated.
Okay.
You were talking about the 3 types of learning before, and you were talking about overfitting. Do you think
Yeah.
that one of the learning types is more susceptible to overfitting than the others? Or do you think they're all pretty much the same?
I don't know. What do you think?
I imagine you can overfit all of them.
Yeah.
But maybe the supervised learning is more prone to it.
Maybe. I hadn't really thought about that. That's an interesting question. Let's see. I mean, you can definitely cherry pick things, right? When you're doing supervised learning, you're picking the data you want to. You often, well, I don't know if you're picking it, but there may be a tendency to do things in a way that makes it very good at some narrow domain of tasks that you design it for, but it can quickly get outside that domain, and very easily just not do good on anything outside that narrow task, which is often okay because sometimes you just want it to be good at that task. But yeah, what do you think?
Yeah, another question I had too was, so when people are saying like a model, I feel like that's a very overloaded term, right?
Huh.
So can you like for example, can you have one model that uses multiple that was trained on multiple learning styles like this? Like could you have one model that was supervised and reinforcement, or would that really be like 2 models that are kind of combined together in some way?
I mean, well, historically they were separate things, but if you train like classification, for instance. I mean, if you train a function or a distribution, and you want to classify X given what, classify Y given X, that's classification learning, right? Right there. So if you learn to model the data, then you also learn to classify the data. So that's kind of a classification learning. So I guess there are no hard boundaries. It's often difficult to say one thing is this and that's another thing. Like even the way we train large language models, we use self-supervised learning. And so on the one hand, you want to say that's supervised learning because you're predicting Xn given all the other stuff, right? And that we imagine that's some distribution given the context. And so on one hand, we want to say, well, this output, this is a labeled data because we're looking at this data and we're saying we want this. So in a sense, that's a supervised learning, but it comes for free though, right? Because we're just looking at reality or words, like the brain, it learns to model its observations it gets from all of its sensors. And it doesn't, we're not label things. We just say, okay, I guess it was a causal label. Say, okay, this thing is probably dependent upon all this stuff. So on the one hand, you want to call it supervised learning, but on the other hand, you want to call it unsupervised because you don't have to do anything special to annotate the data, to label the data or anything else. And in the end, it's also learning this function. And that's the most powerful thing you can learn. It's a very crude approximation of it because usually it doesn't see like this thing, the context, what it's conditioning on. Often it only sees like the last K tokens. When in reality, there may be like, well, maybe infinity or just like maybe n much larger than K. Of course, some recent advances are all about making that K larger and larger, making the context window larger. And of course, there's other things you can do too. Like our brains don't just model, like don't do it this way either. Our brains have some way of recalling, having memory and recalling information stored in some other kind of way, and then it kind of able to augment its context with that information that it learned previously. But it's interesting that many things in these language models and generative AI in general are kind of doing the same things or benefiting from the same things that we do. Like, so I'm not sure where all this ends up, but it's fascinating. You had any more questions about this slide, or? I'm gonna go to the next slide. And the final one is reinforcement learning. This is like an agent. This gives a like an eight. Wait, I think I already talked about this, didn't I? Yeah. There we go. Okay, neural networks. That's where everything's happening right now. And of course, as we all, well, there was AI winter, and these things just went off the radar for a while. People like Jeffrey Hinton and John LeClune, they I think I said that wrong, but they've been working on this stuff for decades, largely in obscurity for a while, but now of course they're the heroes of the modern AI. And a neural network is a universal function approximator that can learn to represent any function. like earlier we was talking about F, you know, and probabilities. These are both functions, and they can learn to. Well, this is you might not think this is a function, it's probability distribution, but that is actually a function because it's learning to map, you know, the input, learning to map the context to a bunch of numbers. All of which sum to one. So this is what it's learning, is learning. And this is why self-supervised learning works so well for these large language models, because now when you have a probability, I don't talk about this in the slides anywhere else, but when you learn this, then you can use, like, let's say this. Let's say our neural networks parameterized by theta. These are the weights. And we have data. Well, now all I gotta do to learn these weights is to take the, you can look at all the data you have. And then maximize it. Find the parameters that maximize this thing. This is this maximum likelihood estimation. When we're pre-training the models, like just learning to model the data that we're looking at, the raw data, that's this maximum likelihood estimation. It was invented by Fisher 100 years ago. It works really well. It's very universal. You know, you can you know, it's a very powerful tool. And so that's what these things are doing at this stage in the development. And use this to find parameters that maximize this thing. And of course, each one of these things is one of these things. You know, like this thing, XJ, maybe it's this one. There's an aside here that when we sample these models, you know, we use this distribution, like, you know, 0.1. We actually sample XJ from given the context, right? This is not actually what we want to do. This is a greedy algorithm. We're just finding the next token that maximizes it. Really what we want to do is maximize, you know, overall possibilities. But that's computationally expensive. And when we're sampling at inference time, you might want to do that too. You know, I don't want to just take the next token, because maybe that gets you stuck in a weird situation where you said something that's incorrect. You can't backtrack because it's just an AR model, and so now it just keeps chugging through that sequence, even though at this point it's very unlikely to occur. And that's because they did a greedy algorithm. They didn't look very far ahead. They just looked, what's the next best token? Of course, you don't just pick the next best token. You sample over that distribution. But that's the idea. And you actually want to, like, maybe sample, like, let's sample the next. Maybe it's something simple like this. You don't have to do too much, but maybe you want to sample the next best 5 tokens, you know, given the context. Or I should label these differently, but that's also known. But it's you know, we can compute that kind of with this function. But it's you have to explore the space of possibilities. And once again, that's the curse of dimensionality. I said that wrong, but So I think I said enough about that. Did you want to say anything about this?
The term network in neural network,
Yeah.
where's the network part come in?
Oh, they just call it that because you imagine these nodes. You have some
Is it-
input.
Is it Ethernet or fiber?
I'm going with fiber because
As long as it's not AT&T Cellular.
and so these are the inputs going into these what you call these nodes, and they output something called the activation, based off some nonlinear combination of the weighted inputs. Like you probably all seen this kind of notation. Can't remember how it goes exactly, but you have this kind of input, and you're just doing these nonlinear functions over all the inputs, and at each layer you do that over and over again. You just add a bunch of layers, and it's able to model all kinds of complicated patterns in the data. If you don't have this thing for I think this math is wrong here, but if you don't have this thing, this nonlinear component, then all it is matrix multiplication, and that's just purely linear. So you want to do something a little more advanced, but this thing can just be this though. This function, it can just be this. Straight lines, but at this maybe 0 instead of going straight, it just goes up. And then I think they call those ReLU functions, vectorized linear units. These turn out to be very good. Before that, they had other ones like sigmoids and other ones, and you had all kinds of problems with vanishing gradients and exploding gradients, and various tricks have been designed since then to get around a lot of those problems, and we're also very accurate at producing. Now, when we learn the parameters of a neural network, we're using backpropagation, which is just let's say you have a function of theta. Backpropagation is this. If you want to learn the derivative, the partial derivative of this function with respect to the jth component, that's what you do. If you want to learn it for this function, hopefully you can see that, but well, this equals g. This is the partial derivative times. And backprop is just a way of doing this this computation very efficiently. So it can backpropagate through thousands or whatever layers and only do these computations one time, and do it very precisely too. And well, backprop doesn't do that necessarily. But we have things like computational graphs that help do all these very intensive numerical computations, but they're very accurate now, and that's what lets us scale up to these massive neural networks.
There's a question in the chat. Has anyone touched on untraining, a way to get the model to forget data that was previously trained on? That's from Hayes.
I haven't did too much research on that. I know it's a very important topic. Like look at humans, obviously a big part of our the way we operate is we forget things that aren't relevant to what we're doing now. We have this way of forgetting things that aren't important and remembering things that are important to what we're doing.
Well, I was more so asking, if somebody, there's a difference between training and LLM, right? On on your data set, versus adding knowledge embeddings to it after it's already been trained. Is that correct? Am I using the right terminology here? I don't even know the proper terminology to use, but would that be
Okay.
accurate?
Can you repeat that?
Training an LLM on your data,
Yeah.
or training an LLM on knowledge-based embeddings, I guess you could say, or versus, so the difference being you're adding knowledge to the LLM where out of the box, prior to you giving it any other information by using human language, it's prepared with a knowledge set of your data versus the default LLM, and it's one of the default versions that has no ability, it doesn't know anything about you or your data, and then you afterwards train it on knowledge specific, knowledge embeddings either through raw text or Excel sheets. I guess the question I'm trying to ask is, in either use case, can you untrain it if you accidentally feed it wrong information, or is this a restart from scratch every time? Does anybody have a solution for
Well, I
that?
guess it depends on, like, if you're just talking about like RAG, Retrieval-Augmented Generation, like finding, like you mentioned embeddings, that kind of implies that your idea is that that you're storing data external to the network, external to the neural network, that's not in the weights, but
Correct. Yes, that's what I'm referring. So the two, well, you could do it two ways. So I was actually asking about each way separately.
okay. When you do retrieval like RAG, you can definitely forget that. Just don't use it or remove it from the database. Then, and you can add things to it too, and then you can do that as much as you want. Of course, these language models only have a finite working memory. Their context can be easily overwhelmed. Then it's not useful to just throw a bunch of stuff in there. The most effective way to give them memory and reasoning about things is to embed it into weights. Train it, pre-train it on that vast data set, and you do that, then they don't have this problem with the context length because they're not using the context necessarily in that way. I mean, they still do have a context, and they're still learning their behavior based off that context, but they're much more capable. They don't get overwhelmed by all these perhaps unimportant details. They can just learn from the raw data and train on that, and that's probably pretty hard for it to forget, or hard for it to undo or whatever. That's just set in the weights, and you can give it more data to change its behavior and retrain it, and you can let it adapt to this new data. But if that new data is like bad data, and all of a sudden it finds itself in this different weird state, it's no longer able to do good on the previous data. That is more important. Then yeah, it's probably gonna, it's not gonna be able to forget all that stuff, and this is gonna be different.
Is there a situation where you'd recommend pre-training the LLM with weighted scores correctly into the LLM knowledge base for prior to, I guess you could say? I don't really know how to ask the question correctly, but I'm, I guess, just trying to understand if everything about your data should come post training through those knowledge embeddings, or if there are use cases you've been able to identify to apply it to prior to the LLM being trained.
Yeah, you kind of talking about fine tuning, right?
Right. That's it.
Yeah. You have some data that you want to make the model better at doing some tasks like mathematical reasoning or whatever. Give it a bunch of examples for that. Ideally you will give it examples, like if it's like whatever task you want to do better at, you can just give it a much more data for that, and it'll get better at it. It may forget how to do other things that it was previously good at too, but there's ways
or it could get worse, right?
I say it can get worse at other things. there's a way to try to counteract that, you know, by not only maximizing the likelihood of the new training data, but also penalizing when you get too far from the original distribution. You can use like KL divergence and things like that. But yeah, I mean, you can definitely have it do worse on the previous data when you fine tune it for this new data. And but a lot of times it's worth it, you know. And of course, you know, you can have a bunch of models though, you know, like when you fine tune one, you still have the original one somewhere around there, and maybe the fine tuning is just adding another layer to the neural network, and it can switch those out in and out as you please, and there might be various ways of choosing that too, you know. But they're very composable in some sense.
Interesting. I hadn't considered that. Yeah, but thank you. And do you recommend if you are making an attempt to the difference between fine tuning and knowledge embeddings is what? Could you explain it real quick to me one more time?
Yeah. Well, knowledge embedding is just where you just in some way you have some data that's external to the network, like maybe a database or a vector database or whatever, it doesn't matter. And you want to find a way to put within the context of the language model some facts about that, so that it can do the continuation it can do prompt continuation based off this enriched context. It's not just based off what it's seen before, but in the immediate past, but maybe what it's seen a long time ago, or what other people have seen or done, like various tools or whatever. And you want to put that into the context, try to make it do better at some task. And that's a very different mechanism than the weights of the neural network. Two different things. The nice thing about the RAG, when you take this external data and put it into the context window of the language model, is it's very adaptable. You can have as much data as you want, and doesn't overwhelm anything else. It's independently parameterized, and so that's a nice feature about it. You can in a sense train the system, not the neural network, but the system as a whole, to do better at certain tasks over time. So they can do learning, but it's not the learning that's done by adjusting the weights of the neural network. I think probably a lot of our learning is the same way. You know, we have this memory, but it's probably not exactly like a weight, like weights in a neural network. It's probably some other mechanism, like the hippocampus has almost a different way of doing things, but it's where our memory comes from. I'm not a neuroscientist, so don't listen to me on any of that. But yeah, I mean, it's all very fascinating, and there's also ways of not just, you know, you can also train these things end to end. You don't just have to have this separate retrieval mechanism. You can actually, while you're like pre-training this model or fine-tuning it, whatever, you can give it access to this retrieval augmentation, and you can have it learn how to do that too. That can be part of its extended mind, you know, and it can train those too and learn how to use that tool better too. So, and it can maybe prioritize, you know, things that it should memorize in its weights, because maybe when it learns in the weights, it can see more patterns and do more compositions, and saying things that it should just learn through rote memorization, because maybe it's like Paris is in France, you know, maybe things that it's just kind of disconnected facts, and you just want to be able to look it up efficiently. And then that may make the neural network much smaller and more computationally efficient. It's still a lot of research in that direction, but yeah, right now the way most people do RAG isn't doing any of that, and of course the research scientists, that's what they're doing. They're trying to get that to work better.
Well, fair enough. Thank you for that. And is there a third-party open source service you'd recommend for that?
I haven't actually did any of that yet. I haven't messed with RAG or anything. I actually just got a GPU like 20 days ago.
Oh, did you get what 49? Or did you go?
I went with 3600.
Oh, okay, very cool.
What do you have?
3060,
Yeah,
but I'm hoping for, I want 24 gigs of VRAM personally.
yeah, me too. Yeah. I mean, you can run these very large models if you have enough system memory and just run them very slowly, but that's not very fun, you know.
Right.
There's enterprise HBM2 GPUs on eBay. A few people are talking about it. I think you can get them at 16 gigs and 24 gigs. Pretty cheap. They're like $100 a pop.
Oh, wow. That's not
Really?
bad.
Yeah, they're headless technically, so they're good for running AI. You can't really run anything else out of them, but yeah, they work. I can't remember the specific model number, but there's some big data center got cleared out and switched over, so they're selling all of them. And there's a bunch of enterprise series ones.
Do
Yeah,
you know who
pretty
the
cheap on
seller
eBay.
is? Do you know who the
It's more of just search HBM2 GPU
HBM2?
or the NVIDIA HBM2 GPUs, and they pop up. There was some NVIDIA ones. There used to be some AMD ones before that. I can't remember what they were called. They constantly pop up on eBay. There's quite a few enterprise GPUs of 16, 24 gigs and even higher for not very expensive because they have no real use for a lot of people in
Huh.
this world.
Wow. That's unbelievable.
I'll search around and post some links in the chat if I come across them here shortly.
Okay. And is anybody familiar with LangChain and had any integration with LangChain on LLMs or no?
I have some, I guess earlier I was messing with it. Although when I was trying to get my my application to work, I ended up just not using LangChain. It kept getting in the way. And
Oh,
maybe
okay.
it's just, yeah, maybe it's just maybe it's just a new technology and I didn't have time to really perfect my use of it. But I ended up, my intention was to actually use LangChain to develop the application. But in the end, I just dropped it and just started just handcrafting the raw strings, you know, taking these F strings and just manipulating those. There's got to be a better way, but I had like a day to mess with it and to get it ready for this presentation, and that's what I did. So,
Okay.
but
Well, thank you for putting this together. This is definitely an area of interest of mine, and I've actually got an LLM running with speech to text, text to speech, runs
Yeah.
all locally on my machine, and
Yep.
I'm trying to add now memory to it. And every time I do, it's not maybe my data is not being input correctly, and I was wondering if there was anybody that thinks that they might be able to help with something like that.
I mean, give me time. Let me look at it. I'm sure we can talk about it and probably do something with it because
Okay.
you're talking about using RAG or whatever to help you like talk to your PDFs or whatever.
Well, PDFs or raw text files or Excel.
Yeah, whatever. Just anything. Yeah, yeah. I mean, I'm sure we can. I mean, I think I have Olama web service running that does that, but I'm not sure. I've messed with it much.
And one last question: is anybody familiar with any like cheap? If I don't have a 4090 and I'm tired of it, is there any online platforms I can use to train an LLM on my data set instead of having to purchase a 4090, something that's a somewhat reasonable cost?
I thought all cloud computing rentals were expensive. I haven't found a cheap one yet or a reasonable one.
I mean, should it be costing me $50 each time I want to retrain on my own data?
Oh, you're training on it? Are you fine tuning it?
Yeah, fine tuning it.
Oh, yeah, that'll cost you money if you're doing that.
Right. So is anybody familiar with like would anybody recommend any third party service?
I haven't used them because this seemed too expensive.
Yeah. Okay. All right. Fair enough.
But plus, I was just playing with my own toys. I was just using it. I have started to do a fine tuning project on GitHub, but I haven't looked at it in a couple of weeks. But my intention is to get back to it and fine tune something that's good at the application. In a bit, I'm going to show you an application I'm working on, and
Okay.
it didn't work as well as I hoped. So I'm thinking I can fine tune it. It'd take a very small language model like Tiny Llama and fine tune it for some task. Getting like very high quality training data from GPT-4 and other kinds of approaches, and then training it on that. I'd be curious to see how it does. But anyone else have any experience with fine tuning?
not fine tuning, but I put a link in the chat for it's an Olama tutorial, but they do something sounds similar to what you're kind of talking about, where they feed in the Odyssey by Homer using LangChain, and then they're able to ask one of the language models about that text, and it's able to respond pretty well, it looks like, from this example. So could
Yeah,
check
what,
out the tutorial.
what
Awesome.
they're doing, I'm sorry.
Thank
go
you.
on.
Thank you.
Yeah, what they're doing there, and I haven't looked at it, but I would guess it's not fine tuning. What they're looking at chunks of the data at a time, and seeing, like you could just do a search on it and ask, like very crudely, ask the model, is this chunk of text relevant to what I want, and just keep doing that. And the other approach that's commonly used is like using these embeddings that you were talking about. But that's not fine tuning though. Fine tuning is a much more intensive process where you're adjusting the weights. Usually not all the weights of the neural network, but like some subset of them. They specialize it for a different task.
Understood. Thank you. I've taken up more questions than I
I
deserve,
don't mind.
so thank you.
I found those links. One's for the NVIDIA, or sorry, the AMD Instinct, and then the second one is the NVIDIA Tesla. You can get a Tesla right now, 32 gigs of GDR5 for 120 on eBay.
Be careful with those because they may be it's so nice, but there may be the one with two GPUs grafted together. So each one only has 16. I'm not
Oh.
sure.
I don't know. I know what you're referencing. I'm not sure. I mean, because there's other Tesla models too. There's M10s, P40s. That's why I just searched by Tesla, and so I'm not sure model specific, but none of them are very expensive.
Yeah.
And can't you use more than one GPU on an LLM?
Sometimes you can, but sometimes like the bandwidth between them is not enough to really benefit the. I mean, I guess it depends. I don't have enough experience with it yet, so I can't speak very confidently about it. But I know there are problems with it, and they're always trying to find ways to make the bandwidth between these different GPUs very fast. But I don't really know though. But my guess is you run into problems when you try to transfer data between GPUs if it's not over a super fast link.
Oh yeah, that makes sense. I was wondering when somebody was going to release some version I could, string a few GPUs together, because you're right, they're all isolated, they're all, I mean, nobody's done it.
I mean,
Probably a good reason for it too.
yeah, I don't know. I mean, it seems like in theory it should be possible, right? Of course, the devil's in the details. I don't know. I mean, it seems like these neural networks are very distributed by design. Like you can run one layer, somewhere in California, another one in Montreal, and that's fine, I think. But I guess it depends upon how much data sharing needs to be done.
Yep.
And if you're doing inference like end to end, like going from the input to the output, that probably needs to communicate across the entire. It's probably very connected, and you need to communicate these values across the entire network. And if they're spread out, that may be slow. But I don't really know.
Fair enough. Just I would say everybody's working on this. Be careful
Yeah.
letting it make its own decisions. Rather let it provide information, but allowing it to make decisions is a little bit of a problem. It's going to result in a major mess up. So just be careful, I guess.
Fair enough.
Thank you, guys. Thanks.
Thank you.
Couple quick references from the chat. Collards mentioned there's a 5-minute video on building a PDF reader with a queue and a front end. Check the chat if you want to pull up that URL. Let's see, there was also a comment about just started learning language chain. It's a bit more briefy than semantic kernel. And those comments actually go back a good 10 minutes. So sorry I didn't get them in earlier. So anyway, turning it back over to you, Alex.
Okay. So where was I at? Maybe I'll skip this stuff because it's getting kind of late. But well, quickly, an inductive bias is anytime you look at something like your observations or training data, usually there's many different models or parameters in neural network that are equally good, that explain the data or are compatible with the data. And so you need some way of choosing one model over another one. And this is usually where, inductive biases come into play. Some set of assumptions the model makes about the data. I think Occam's razor is a classic example of this. All things else being equal, choose the simplest model. I've been a long supporter of, or long fan of, Solomonoff induction, and this kind of a digression, but I view Solomonoff induction as kind of the end point of all this. Like these large neural networks, these LLMs, they're kind of doing an approximation of Solomonoff induction. But Solomonoff induction, of course, if you know anything about it, it's not computable. So that's kind of a problem. But the closer you can get to it, the better off you are. And that kind of Solomonoff induction represents kind of an upper bound on performance. So how it is, we want to generalize out of distribution from inputs not in the training data, so that we can think about the future and do things that are sensible in new environments. But that's because we're almost always in these new environments. We're always out of distribution, especially in these high dimensional spaces. So good inductive biases are necessary for generalization, but there's a well-known theorem called the no free lunch theorem. No model is optimal for all tasks. You just want it to be good for the set of tasks that you find yourself doing a lot. A lot of tasks aren't very important. You can imagine a task for anything. Most of the things don't even make sense to us. Is this not something that would be relevant to what we want to do? So you want to find a way of selecting those biases that help you do what you need to do better.
I like the idea.
So now, like probably 12 years ago, 10 years ago, the era of deep learning kind of came onto the scene. One of the hardest problems is learning what you call sample efficient representations of the data. And you need to do this because, and this is actually just back to inductive biases again, but you want to learn sample efficient representations so you don't have to see all the data. You just want to be able to see a small set of data and then generalize from that. And so in deep learning, the layers learn progressively higher level of representations, and that ends up being a very good kind of bias, kind of representation learning. And AlexNet was introduced in 2012, and it just totally dominated ImageNet competition. Out of nowhere, when AlexNet entered that competition, I think they were the only one using a neural network. And they won by a landslide and totally changed people's expectations about what's possible. The next year, like almost all of them were using neural networks. So that was just a flip. And a lot of people think that these deep neural networks are learning tiny little circuit programs that can generate parts of the training data. For some reason I'm not seeing. I have actually there's images here too. Do you see images here? I think my images are gone. Does anyone see an image right here?
Nope.
No, we're not seeing images.
I just noticed that a bunch of them are gone. I had the image here too. Maybe I can reload it.
We see you drawing, but
Yeah. Let's try this one. Okay, yeah.
yeah, there's your images.
Yeah, I'm going back to this, the pure markdown. All right. I'm gonna go ahead and close that. And
That helps.
oh yeah,
Yeah, that looks a little different.
yeah. So okay. Anyway, yeah, here was ImageNet. It was released on this around 2012. Here was the previous state of the art. It came on the scene, and this 50% was state of the art after decades of research, where people handcrafted all these feature representations. And then DeepNet came on, and what it did is it learned how to represent the data by itself. Representation learning was no longer something humans did; it was something the model did. Like before, researchers were hand tuning, like ways of detecting edges and things like that, and ways of seeing where there were boundaries on objects, and it was all very technical, and we weren't very good at it because it's very hard to do that. But then ImageNet comes on the scene, and or this, I guess, AlexNet, and I think the people who did AlexNet never even messed with image classification before. They just knew about neural networks. They applied it to that problem, and it did 13.3% better than the previous state of the art. And as you see, it's just been going up and up, and since then, now it's 90.88%. That was around 2021, I guess, or 2022. And that's apparently better than humans.
And what is this y-axis?
This is the accuracy, like the proportion of things that they classify correctly. Like say you show a picture of a leopard, and you say, what is this? This seems like an easy problem nowadays because we have these image transformers that can reason, like multimodal models that can reason about images and do all kinds of things with them. But yeah, is this how many of the images do you quickly classify?
What's the legend on that y-axis? Looks like top something. I'm sorry, the vertical axis.
Oh, that's the vertical.
Yeah, what's that left-hand margin or legend?
That's top accuracy. I can't see what it says. Let me zoom in on it.
Okay, all right.
But is this the accuracy on it? Like maybe it's saying like I'm not too familiar with it. I just know that it's the verticals some measure of accuracy, whatever they do in ImageNet, and the horizontal is just the year. So now with deep learning, we can do all these kind of problems. We can take an image and classify it. We can take a audio waveform, say, okay, what is that saying? How cold is it outside? And we can do machine translation. I think I could cut off there, but and we can also do like image captioning. Like now we're not just doing a label like leopard, but we're saying what's happening in the image. And it seems like these deep neural networks, they have so many layers. It's a fixed amount. They don't have any recursion, but they have so many layers, and they're very good at learning representations and how to do these kind of tasks. And it seems like anything a human can do, maybe in like half a second, without much thinking, just kind of using our intuition and our pattern recognition brain. It may be the case that these deep neural networks can do that too. So we kind of solve the spatial problems that take half a second to solve. Now we want to solve the problems that take, minutes or days or hours. And that's where all the research is right now. And now we have, the era of generative AI. I'm losing my voice. Sorry. So that's where we're at now with all these multimodal models. Everything's kind of going crazy right now. And so instead of going like, I actually saw these slides from Jeff Dean. He did a recent talk and he talked about this. And but I like what he said. He said, we went from these images, we went from these things to these things. And now with sorry about that. And now with how did I get rid of that? I wonder. I'm gonna close it out because I think it's gonna be there the whole time. Does anyone know how to get rid of that? Oh, here we go. I see now. Oops. There's a eraser right there. All right. It's Zoom's kind of new to me, so I don't know too much about it.
You mentioned that neural networks kind of fell out of favor for a while. Any particular driving reason for that?
They're very they're very capable models, but they're hard to train. They require a lot of data. And so back then we was training on very small data sets on very small computers. And now we scaled up to massive data sets and massive computers. And suddenly they're doing better than everything else. And some people called that like Richard Sutton, the father of reinforcement learning, kind of predicted this would happen. That the easy approaches that scale up are like very easy to paralyze and all that will in the long run dominate over everything else, because the most important thing is not some clever algorithm, but just being able to crunch the numbers and look at massive data sets. So that's the main reason. Just we didn't have enough computational power yet. Back then we had the computers that were as powerful as a cockroach, I guess, And now, of course, we have much more powerful computers. Still not as powerful as the brain, because the brain still has more parameters or whatever you want to call that. But at least some brains do. My brain, not so much, but kind of lost my place. Okay, I am way far down. Sorry about that. Okay, yeah, so now we're in this new age, and we're kind of reversed the input, the output. Now we can take a leopard and we can generate, we can take a description of a picture like leopard, and we can generate a leopard, or we can say how cold it is outside. And I mean, text-to-speech has always been possible. Text-to-speech has always been possible, but it's got much better lately. If you tried any of those new models, they're pretty good. You can also, if you have your own GPU, try running Bark by Sona AI. I think that's what it's called. It can do very impressive. It's not just a speech generator. It can do any audio, so you can make it laugh and things like that. It's kind of cool. So now we can we can even take a description of something like, and then we can generate an image that captures that image or that description. And of course, we also saw what was it called? Sona. What's that one video generator? That video thing called? Where it can make videos.
Sora?
Yeah, Sora. Yeah. Yeah. So now we also see Sora, and that's this whole new level. So now we have computers that can see, hear, understand, and generate all these things. So we won't do that again. We're looking at Sora, but many people think that Sora is basically like a world simulator. Some people don't think so. They think this is a dead end, and this be cool for making videos and stuff, but it won't enable like type 2 or system 2 reasoning, because it won't be able to be grounded in reality, or doesn't have a world model. I think they're wrong probably, but we'll see.
Well, isn't there some sense, because like kind of touching on what you guys asked earlier, it's hard to get them to forget what they've know or further retrain them, where it takes a lot of effort. So it's almost easier to a point to start over. So even if SOAR isn't necessarily a dead end, some new innovation will come along to where some training part or something will be more efficient. So thus all old models are almost out of date in a sense, or will be.
Yeah, my guess is that every 6 months or a year, we're going to have a whole new generation of capabilities. But yeah, I agree. So the amazing thing is, there's what we call the scaling laws, and it seems to hold that as you increase the number of parameters of these systems and the data, you get almost predictable you can't predict the exact capabilities, but you can predict like the complexity, like how good does it predict the next token or the next word. That follows like a power law curve very well. So you can make predictions about, well, I'm not sure what it'll be able to do as far as like competencies and skills, but it will be able to predict the next word with this level of accuracy. And usually when we get a prediction, we also get good at everything else, because prediction is the right kind of thing to optimize. If you can look at some text that says, based on all the evidence, I conclude that X did the crime. If you can do that well, predict that X variable, then that means you, in some sense, reason about the past, reason about all the evidence that you were exposed to, and came to an informed decision. That's kind of what reasoning understanding is. Of course, a lot of debate about that. I mean, right now we're learning so much about the brain too, just based off learning about these large language models. It's a very fascinating time to be alive right now. So one major hypothesis is, prediction equals compression equals intelligence. Compression in the sense that we're finding these very, what's that? Compression, because we're learning these very efficient representations. Prediction, because if you can compress something, you can actually use that compression to predict it, and vice versa. You can use like an arithmetic encoder based off your predictions to do a very good compression. And if you can do compression or prediction, then you can also generate intelligent behavior by sampling from those predictions. Now, I think you probably also need to do search in a more advanced way for like long-term planning, but they're all kind of related in some way. And if you look up Slomanov induction, or even ICSI by Marcus Hutter, Hutter uses Slomanov induction to propose a model that is, in some sense, an optimal intelligence. Like you can't do better than it. But of course, that's also incomputable. But it gives us like a hypothetical upper bound on how smart something can be. So now we're going to talk about just language models. And most of these models are what you call AR, autoregressive models, because they learn a probability distribution over training data by using self-supervised learning. And that's just, let me get my annotator out. That's just, to learn this joint distribution, we just look at all the training data, we condition on that, and we predict that, and then we just find the parameters of the neural network that maximize this. I said earlier, that's just maximum likelihood estimation. But this is a hard problem to learn. Fortunately, right now we have so much data and so much compute power, it's starting to become possible. And that's what gave rise to the modern LLM. And also, there's a nice advantage to language, because earlier I mentioned that language has a very efficient, a very high signal to noise ratio. So the representation learning part is a lot easier, but it does learn representation, like word-to-vec and all these embeddings. What that is a representation. And it does a pretty good thing too. Like with word-to-vec, like if you look at the first layer where it doesn't look at all the context and it doesn't look at the entire context, just like the first layer where it's just looking at tokens. Now it may have this space right here. And it may put dog right there and canine right there and maybe a cat right there, but like a chair right there. So these embeddings are in some sense capturing the relationships between these things, these tokens or words. So it's been shown that often the case is that if you take token for king, if you take the token for king, I can't write it out, and then you subtract, here, these are vectors, and you subtract the token for male, man, that more or less ends up in the same space as if you take queen and you subtract woman. So you kind of get, and maybe they're both kind of close to dictator, which is maybe more neutral in gender. So they're learning all these representations, and the deeper into the layers you get, the more advanced, the more subtle, the more contextual, the more global the representations are. Those final layers are where we use like RAG, Retrieval-Augmented Generation, and all that. I need to delete this thing again. Not kind of losing my voice. Okay. And language, like I said, it is a very powerful tool we have. Now, humans are tool users, and language is one of our best tools. And we more or less use it to discuss and think about all the problems we care about, which is why learning how to generate and predict language is so powerful. If you do that well enough, in some sense, you have something that can use tools that can reason about the world in largely the same ways we can, especially with like chain of thought prompting, where you really spill out all the missing details. And so now we have like these sparks of AGI. Like AGI stands for artificial general intelligence. Now, that's kind of a moving target. No one quite knows what we're talking about when we say that, but we know that things are getting more intelligent, more human-like, and probably in the end much more advanced, because it'd be hard to imagine that human cognition is like the upper bound of what's possible. Very likely that will be far surpassed. I'm not sure what the implications of that are, but even like Alan Turing, a long time ago, he says once the machines, become smarter than us, we should have to expect them to take control. That's a very controversial statement, and I don't know where I stand on all that. Right now they're so weak by comparison that like I'm messing with these small models, they don't seem that intelligent. So I'm not too worried about these small models, and I feel okay exploring their full capabilities and releasing them open source and all that. Maybe we'll revisit all this with GPT-5. I don't know. Does anyone have thoughts about safety and alignment and all that?
That sentence right at the top of the screen right now about language is designed to have low dimensionality.
Yeah.
What do you mean there by language
Well, like,
low dimensionality?
like, are you familiar with the expression, a picture is worth 1,000 words?
Yeah.
So kind of like that, a picture has like 1,000 words in it. But it takes 1,000 words to represent that picture. So each word has a lot less information than a picture. And of course, when we look at the world with our eyes, we're seeing these pictures, these frames over and over again, and they're just like the raw data process from reality. It's not crafted to suit our capabilities. It's this reality coming into our senses. But language, we use language to communicate clear. We use it to be very precise with our language, to communicate things that we care about, not things that just happen in nature. So it's been crafted and fine-tuned to deal with the problems we think about a lot. And language is also what you call symbolic. A token has a distinct meaning. There's only a finite number of tokens, words, and even if we think about all the words that are possible, sequences of them, that's still countably infinite. So there's a sense that these things are much less complicated, but they have much richer signal. They carry a lot of meaning that's valuable to us. But but an image though has all this stuff in it, noise, like a bunch of noise that will fluctuate based off the time of day, the angle of looking at it. This is just much more complicated data structure. And but language is this this discrete set of symbols that we use to communicate.
As
Okay.
far as you had a question, or you mentioned legality or how we're going to regulate it in the future, or like AI sentience, I wasn't sure. I don't. Every model, the longer it runs, the more incorrect it gets over time. OpenAI has admitted it. I think that's kind of the secret why Tesla's having so much trouble with driving cars, is the longer it runs, the more, because everything it has to be reinforced, or it has to have the weighted values reevaluated, and it's going to constantly hallucinate at a greater and greater percent the longer it's been running. So even
I see what you're saying.
yeah, so even if there is some hyper scary AI that takes over the world, it's only, I mean, I've watched a bunch of video or webinars by the Aspen Institute and NIST, and they're definitely talking about regulating it and stuff, and trying to, and being ahead of the curve. But even if it did, it would be borderline incoherent in a couple days because it is so smart. It's gonna get so off on some tangent, on so many, it's all at once on so many different things, that it will be hard for it to get back in its wheelhouse. Because I mean, it's happened with all the AIs I've come in contact with, even the expensive ones.
You make some good points. Maybe though, think about this. When humans make predictions about the world, and we do that, we're just modeling the world, making predictions about the future. We're constantly getting feedback from the world, and we're constantly trying to, okay, I thought this would happen, but this happened instead. So I'm gonna take this information into account, minimize my error, and I'm gonna recalibrate based off what I've seen, what I'm seeing from my sensors. If we would just run a language model by itself, yeah, it may just get more and more out of distribution and more incoherent. But there's a sense in which that you can also ground them, like when you compile, like when you run a Python program, it makes a Python program, then it runs it, and it says, okay, then it's fed back the error messages, and it's, okay, this is what's wrong with it. So okay, then it won't get worse over time. It'll get better over time. It'll make the program more and more correct. It'll counteract that hallucination. I mean, hallucination is actually good. That's what we want. We want to be able to entertain possible worlds, possible futures, but at times we also want it to be grounded in reality, what's happening. And I think this is a grounding problem. We just need to take in external data as feedback to these systems and find ways for them to recalibrate. And in some ways they can already do that, but yeah, I mean, hallucination is a problem, and they do get wildly off course if you let them just talk amongst themselves, because they're just kind of doing their own thing. And if you've ever run AutoGen, they can do some crazy things, but it also may just be prompting, like it's doing this. We have another language model that's critiquing.
Those are numbers. No.
But I guess my point is that I'm not sure that's a long-term problem. It may just be a very, very a big problem right now, but I think it's going to be solved quickly as far as like getting reliable outputs from these things.
But to a certain extent, the aren't all of the models somewhat biased? I mean, like for example, the with Google's Gemini AI with the whole image generation, as to how it seemed it was biased to producing people of color, or like refusing to produce people like that were like white or Caucasian, even when that was the accurate like descriptor being provided. So it kind of seems like each model or whoever's behind the model is applying implicit or explicit biases as to how the model should run. So are we really going to get something that is fully accurate or capable of being accurate if these guardrails are kind of always in place?
I doubt it. Software always reflects the bias of whoever wrote it.
Even the data sets they've mentioned, there's bias in data and statistics, and it's unintentional too. It's just the way math works out, or the way that because of this formula, or and so the data sets that are fed to these things, let alone the rails themselves, bias can be put in unintentionally in two separate ways, more than one, I guess, indirectly.
Yeah, they're a function of their data. I guess so are humans, I guess.
Your comments about the AI basically going crazy after a while. Do you ever watch large weather models? They go nuts after about 72 hours.
Do they?
Yeah, they don't predict anything useful. That's why they're always in a weather bureau when they're doing this. As fast as they can turn it around, they run it for I don't know how many hours, and then they shut it down, start it over with, whatever their initial conditions are.
And that's actually the truth with AI. It does the same things happens with OpenAI and with the Elon's cars. They have to basically reset the neural model every so often. I've even noticed this with OpenAI. Sometimes I talk to it and it's very coherent, can do OCR just fine. It can digest documents very well. It can produce documents very well. And then all of a sudden, 2-3 weeks later, it's struggling to do the exact same thing it could do. And then another 2-3 weeks, it's back on point. It's a known fact that the longer these things run, the more off the rails they get.
Well, with that case, if you have like a long history, like a long chat history, because like each chat session is a separate thing. Like the weights right now are they're
No,
static.
I'll start new chats. It kind of goes into what you were saying, is it has to be constantly reinforced, and us as users aren't necessarily reinforcing it. When it goes off the rails, we'll just start a new chat. Well, then the model thinks, okay, I did a good job. If we didn't do the thumbs up or thumbs down, they're not necessarily doing it internally. The reinforcement, because the model's producing so much, it's an exponential of how much we then have to reinforce, because it's producing hypothetically more and more questionable things that we just ignore and move on.
I mean, like OpenAI they're collecting data like our thumbs up and thumbs down for like RLHF, and that data is being collected and maybe they're training it every now and then, like doing like a run through the layers. I don't know, but it doesn't learn in real time. The weights are static. They're set, and then it just does inference. Just runs through just run through the numbers. So they're not like humans where they're constantly taking in data, updating their model, and then getting better at that, or being more competent at whatever they're doing. They're just kind of fixed, static, and but maybe there's something to that. I mean, I'm sure that it's hard to control these things, especially if they are every now and then training it and updating the weights. A lot of times you may mess things up a little bit.
It is learning off us a little bit to a point because LG and Samsung both got in trouble. Their engineers were questioning it about things that they were designing, and people outside of LG and Samsung were able to get the model to regurgitate the info to them. So it's not, I don't know on what level it is learning, but it is taking what we're asking it about and applying it to other conversations, because there was a big classified thing. The info that came out was technically classified, and those engineers got in trouble. There's a big news article about it.
That's like a new way of hacking.
And well, that's why now if you ask it to give you your phone number or something, it's specifically known not to. So they had to put a thing in place because it was giving other people's info that it was told by that person. Let's say you upload your resume. Well, it knows your address, and it didn't know not to share that.
Could this
So it was for a while.
Could this
Wow.
actually be like a search where there's information on the web and it has a web search feature and it's looking up the data from that?
It's no, the articles were referencing data that it was specifically given by engineers that was classified, and it turned around and gave that info to other people when they were asking things that were similar that weren't. It was, let's say it's a plane that you upload classified plane stuff, and these other people asking about a plane, the AI references the data you uploaded, without even. It's been done a couple times. They had to kind of change it so it doesn't do that anymore. So I don't know if what you call that. I don't think it is quite learning because it's not changing the model, but the data we're giving it is interacting with something.
Well, my guess would be that I don't know too much about that, but it could just be that they are collecting this data from us. All the data will be used in the future to retrain them, and they could just be doing retraining. They could be retraining all the time. And so if you give it information about something, maybe it learns about it, and the next generation of the model, 4.1, not even given a version number, but the next update may have some of that knowledge incorporated into it. I don't know. I don't know too much about that. I know that training them is so expensive and computationally intensive that they're not doing it constantly. Like humans are just constantly retraining, but these models, the way they operate is they do these large batch training runs because that's how it's more efficient to do it. And they also like to take the data and kind of curate it, make it higher quality data so that they don't learn a bunch of crap out there. But yeah, of course, the pre-trained model, it's all the crap out there. But I don't know much about that. You have to show me some links to it.
What do you think about benchmarks? Because I keep seeing like, oh, Gemini is better than GPT-4 and these benchmarks or something like that. But that makes me wonder, like, how do you evaluate how good an AI is compared to another one at certain tasks? And what do you think about these benchmarks? Do you know anything about this? And are they legit or are they just marketing stuff, you think?
There's this famous expression that when the benchmark becomes the target, and it's no longer a benchmark. So what's often happening is some benchmark comes out. So, okay, we want to get good at doing that. We want to get good at doing that. So they get good at doing that. But once you actually specialize it or in some way target your performance to be good at doing that, it's no longer a benchmark. It's something else. So what's often happening is they're kind of just nudging the models to get good at doing those tasks that give them the best bang for the buck or the best PR. And or just implicitly, they just think that they're using that as their measure of progress. So let's get good at it. Let's get good at doing that. So that's one dimension of the problem. Another one is, yeah, I mean, it's not clear how to define the benchmarks or how to go about doing all that. It's sometimes you get a high benchmark on something, and it doesn't mean anything in the real world. Like, it doesn't help its reasoning. It's not clear what all that means. But I know it's being worked on a lot, and people are trying to come up with good benchmarks, because you want benchmarks to be able to evaluate progress and know what to do next. But I'm going to skip this section. This is all cool stuff, but we kind of talked about it already. So I actually implemented a naive, this is the in-ground model. Here's the, on my GitHub, you can Quilius /slug talk, slug-talk-LLM. You can just go to Quilius and look at it. Queelius. There's a collab link there if you're interested. But I'm not sure, it's kind of getting late. I think I'll just explain what I show. And
Are
can
you,
look at it.
so you're saying that last line, that's the slide deck that we're looking at right now, SLUUG talk lim?
So this is the GitHub, and this has the slide deck, but it also has various other things like links to the collab.
Okay.
And other things, and just, well, maybe I'll click on that.
If you could just copy and paste those in the chat real quick, and
Okay.
that would be
Okay,
helpful.
yeah,
Thank you.
Good point. And I don't want to spend too much time looking at this because it's kind of trivial, but it's in-ground. Do you guys know what in-ground models are? So
No.
to do what like GPT-4 and stuff does, I take the dumbest approach possible. I take the context, like maybe the last N words or N bytes. In this case, I have a raw byte model. Take the last N bytes. I use that as a dictionary lookup. That's a key in a Python dictionary. And I map that key to a value, which is another dictionary, which has a key. And the keys are the tokens, the next tokens the next tokens, and the values are the probabilities or the counts of those of that token in the training data. And I just sample from that. This is a Markov chain actually, but it has quite a few number of states. Luckily, the data itself is pretty sparse, so you don't have to. So even though I have pretty large context windows, it doesn't blow up too much. So I have a reasonably small model that can do an okay job at replicating this kind of data. And to run things, just do like shift enter. And I have this basically these synthetic data or algorithmic data. I generate expression trees, like sort. Let me get the annotated. This is an expression tree. I have a picture of it somewhere. And I generate random expression trees, which have deterministic values, but the prefix, the prompt, the context is just random. I just do whatever. And at some point, I'll generate an equal sign, and then what comes next is this is deterministic. So if you get good at doing this, then you've really modeled the data process.
What do you mean by it being deterministic? What are you determining?
Oh, so, oops. So when you give it this as input,
Could you kick the screen size up just a little bit? It's a little difficult.
yeah.
Maybe Control Plus would do it.
Yeah, there you go.
Ah, there we go.
There you go.
Nice, nice.
Okay.
Okay, there we go.
So when I so when we give this as input as context, like in the LLM, you feed it context and it then samples the next token. That's random because the data is so complicated. In my case, this is all random. Not that complicated, but it's random, a random expression tree. But it has a well-defined meaning. Like sum of 4 and 3 is 7, max of 3, 5, and 2 is 5. If you sort that,
Okay,
well, that's wrong. but when you sort that, you should get 3 and 5. So that ignore that wrong output. That was my fault. But
should get
So-
5 and 7, right?
yeah, it's probably this old. Like I didn't update the values and when I was writing it because this is hand coded. But yeah, the idea is it's like a math or program. It doesn't have randomness to it, not necessarily. But it just the input and you map that to a definite output. So my data is a lot simpler than language, natural language. And that's why I chose it, because this kind of data can be more easily modeled by a very simple, dumb n-gram model that I explained earlier, just a dictionary of dictionaries that maps to counts. Here it is. Oh, dang it. So, and here's the code. You want to run it, you can mess around with it.
I posted the articles of it leaking
Mhm.
company documents.
Okay,
It was Samsung, and then Google's attorneys have come out and said that it's leaked internal Google documents, things that are very, very eerily similar. And it's happened so many times that ChatGPT's even had to put in patches, so it would help stop doing that.
Wow.
okay, thank you. I'll look at it
I
later.
wonder what those patches do to the model.
Okay, so you can sample from this, just like I'm gonna generate 10 observations. And wait a second. That's very simple. Let's make it a little more complex. So I'm gonna make you do this. Let's make it a more complex expression tree. So now you get all this crazy stuff. And then you can ask it to, that's probably too complicated. Make it a little simpler. So you generate this data, these expression trees, and then you ask the n-gram model to train on it. If it sees enough data, it will eventually be able to learn all these kinds of algorithms. But it has to see a lot of data. This is the most inefficient way to write a program to do these kind of problems. But is this there for a thought experiment? But of course, you want to train it. You want to probably do like, I don't know. This might be kind of slow on their notebook, but yeah, let me do it. Usually, for an n-gram model to work on these complicated kinds of expressions, you need a lot of data because it doesn't have it's not very. Doesn't learn good representations of the data. This stores it. This as memorization. You know, if you give me a big enough lookup table, bigger than the universe, then that thing can be intelligent. But it's not a very efficient way to do intelligence. And my Markov model is kind of in the same boat. It just stores the raw data and it uses that to make predictions about the future. there's only one way in which this model, here's on your own computer, if you can run it. This is too slow, and it's not worth opening up on my computer. But if you run it, you can do various predictions. Like you do a sum, it'll predict. Okay, when you do a sum, it predicts. I can't see my. Oh, there we go. So when you do a sum, you end up predicting this whole thing. So this prompt completion, it stops at a period. That's how these large language models work. You give them a prompt, and it'll complete that prompt in a way that resembles the training data. This is what this is doing. If I give it this, it just immediately closed it. And this sum of 1 is 1. You give it this, and you then do the equal sign. Well, this is also old, but it would output 6. Unless I've never seen this, I've never seen this input in the training data, they may not have. Then my model, what it does is this, okay, I've never seen this before. Maybe I didn't see this. Maybe it's maybe the context is too long. Only sees the last like 5 bytes or whatever. So it throws away this sum. So it doesn't know what it is. But you know what? It probably thinks this is the maximum. So it's okay. I'm going to imagine this is a max. It takes a max of 1, 2, and 3, and it gets 3. So the context length, of course, having a memory of the far past. Sometimes you have to have a memory of the very distant past to be able to produce intelligent outputs. My language model, if it doesn't have the whole thing in context, it does something very stupid. It just drops the oldest tokens. Kind of inductive bias is the older the token is, the older the observations we're seeing in the past, the less relevant it is. But in this case, it's probably the most relevant thing. This sum is more relevant than anything in this. But my model throws it away, and that's the inductive bias. It's not a good inductive bias for this algorithm because it often ends up throwing away the operation. But kind of gets the point across that the context window, the inductive biases that exist in the model, these things are very important. So I talk about this, and I think I already kind of mentioned all this. So the bottom line is this thing's not very good, and we can do a lot better with large language models. And so I think next I'm going to show my application. Yeah, let's talk about a tool. And now I want to make a tool that can process natural language queries and map those queries to complicated ElasticSearch queries, which is kind of a JSON. And let's see how it does. Where's it at? Okay. Oh, I'll change my content, change my environment in a second. On this one, in the end, I'll give you access to it so you can play around with it. But for now, I'm just going to go ahead and load it. So I have this, but actually I have something else too. A second. If you go on my GitHub, you can read about what's going on with this thing. So the idea is that with these language models, it'd be nice if we made every API endpoint, every user interface, if we made it intelligent, if we gave it natural language understanding. But of course, since it's everywhere, on every endpoint, on every interaction, maybe on the phone, we probably want to use smaller models. Faster, lower latency, you can talk with it real time, maybe it can get back to you and have a conversation. And also the small models, maybe these narrow domain, maybe some of these tasks are more narrow domain. They don't need the big model like GPT-4. So we can just fine tune it or specialize it for these smaller tasks. So as a trial run, I'm going to use ElasticSearch as a back end to enable natural language queries. ElasticSearch is kind of has complicated structure. Like say you want to look for we have articles index, and we want to find we want a count of the authors. We want a count of the articles by author, or count of the authors by number of articles they wrote, and this would be the this would be the can you see my mouse cursor, by the way?
Yeah.
Okay. This would be the JSON query that ElasticSearch expects. If you want to do this, then here's what you need to write. And it can get a lot more complicated too. It can get, you can imagine Boolean queries and fuzzy approximate searches and all that. And it's a very powerful engine, but it's hard to use. And I'm sure there are better APIs for it, but I just wanted to use the JSON and just map natural language queries to the right JSON query. And I just use the fast API engine to write the API front end. I use ChatGPT to write it for me more or less. Before this, I didn't do much front end work, but ChatGPT kind of makes it easy. So we expose a single endpoint. It has a lot more endpoints on it, but the one we care about is this. We say the index name like articles or books, then we say natural language query, then we submit our query. And hopefully the language model converts that to some meaningful JSON representation of the search, and we're good. So as a test case, I populate the index with two indexes, or the articles and Gutenberg, where I just download a bunch of books from the Gutenberg website, all those free books, and I just populate it with just some relevant fields like author, publication date, whatever. Okay, and now let's look at some code. Let me jump over. So I do all this. This stuff's not that important. It's just boilerplate code. Here's where all the magic happens. Or well, it's not so magical, but this is where the attempt was made. So we give it an index, and then we give it a natural language request. It's just a string. but it also has some other parameters like which model do you want to use, Llama 13 billion parameter one, or even OpenAI, whatever the case is. I have a local model running on this endpoint. It's Llama, and it can swap in different models. And this one I'll explain later, but it's basically I used GPT-4 to populate the database to populate a database with examples, high quality examples for given natural language queries on that index. And the hope is that we can in context train the smaller model based off this teacher model. And then we can use a smaller model to do most of the computations very quickly and efficiently. So here's my system measures. I generated from this function. And so let's look at this one. This is an NLQ. Okay. So generate a system message, takes in the this stuff is index and use examples. Okay, so let's first ignore the use examples one. Let's say use examples is false. So it goes through and it gets the mapping of the index. Let me show what that looks like. So it gets the mapping of the index. This is what that looks like. As author field, these things get very complicated. As publication date, this is a one layer list. It's not nested, doesn't have anything going on really, but and title. And based off this metadata and the names of the fields, the hope is that the language model can do a lot of prediction about what these things mean, and then be able to take natural language queries and construct reasonable search queries on your behalf. Let's go back to the code. So here's the system prompt. No examples in this case. Just one shot learning or zero shot learning. Just asking the model to come up with an answer without any other context except what's in here. It's kind of funny how you have to prompt these things. You got to kind of puff them up. You're a world-class natural language to Elastic query generator. Your task is blah blah blah. I had to do this. Needs field keyword because the small models, not GPT-4, but the small models kept getting confused and mixing in old syntax and new syntax, and they just wasn't being very coherent. But this kind of solves some of that. Then I say, okay, here's the index I showed you before. Here's what that looks like. Based off which index you choose, it'll be a different mapping. And then I just I do that, and then I say generate an Elastic query based on the following natural language query. And that returns the content, and then we go back to the main. Here's the system message we just made. We populate the system message with that data. Then for the user message, it's okay. User's turn. Natural language query is request, and then the query that the user submitted. And I submit that to OpenAI, not necessarily because the base. If you change the base URL, you can query a local model. That doesn't have to be OpenAI. It can be anything. So in this case, in the end, I also try my Llama models and Llama CPP models, but GPT-4 and 3.5 were vastly better at this task. And so I started with them, and then I get a completion from the model. Does anyone have any questions? I'm kind of running through this quickly because
It seems like you made a bit of an AGI in a sense.
well, it's not that smart, but I
Not
appreciate
quite, but like in a basic form, because it's doing, yeah.
Well, I wouldn't say that, but I appreciate the compliment. I think it's pretty dumb still, but like GPT-4 is pretty good. But this is just a simple task of 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 doing search queries. So I don't know about AGI, but it's a way of.
Well, I mean, more of it's going out, finding something and then bring the knowledge back to
Oh yeah,
aggregate it, which
yeah.
kind of then falls under the category of an AGI a little bit.
Maybe you're thinking agentic, maybe.
I mean, yeah, maybe, because I just know I've seen people use
Yeah.
that to aggregate data in a sense. And they were
Yeah.
referencing as it as that, but yeah.
Okay. Yeah. I mean, yeah. This is a nice way to use these models. Is they're already kind of intelligent. They understand language, and then you want to prompt them. You want to pull in data, specialized for whatever you need to do. You can you can fine tune it, but not through the weights. You can fine tune it by prompting it, by conditioning it, by giving it the kind of data it needs. And so, in this case, I'm just giving it data about the database, its structure and things like. The more data you give it, in some cases, for the big models, the better it'll do. The small models, they kind of get confused by the context, so you have to be careful. These small models aren't quite up to par yet. Maybe we can fine tune it or something like that, the weights, and they can do better. But that's definitely something that needs to improve, and they are improving very quickly too. 6 months ago, the best open source model was terrible, but now I didn't even bother with them because they suck so bad. So finally, I submit the completion. I say okay, language model. What predict the search query, and this response format just means I want it in JSON as a JSON object. There's actually a lot of interesting research in this area where you this doesn't do it. I think OpenAI, for instance, just fine-tuned their model to output JSON better, like to stick to the JSON grammar. But there's another, you can do something else though, and they don't do those. You can actually sample from a grammar. So it can sample from all these words, but you can say, okay, don't sample from everything. Here's the things that I know are valid next. Maybe if it's JSON, a curly bracket must be next because I saw a key. And then after that, a quote, or the things that the syntax that's valid, and the other stuff you can throw away. So you sample from that subset of the distribution. So it's a conditional distribution, and you can enforce it precisely. But there's actually a problem with that though, because you have to use things like beam search. You have to be able to explore multiple paths simultaneously, because it's very easy to get stuck in some place where it's not able to complete the request. So you have to kind of explore multiple paths. You can't just do a one through. I'm not sure what's happening with here, but I think OpenAI just fine tunes the model to output JSON, and it works pretty well, and it's fast, I guess. And I do the standard notation for calling the model, and then I get another response. This time I have this query. The language model predicted what the ElasticSearch JSON query looks like, given that natural language query. It sets it to that. And then I search. I use the ElasticSearch engine to find whatever the user was looking for in that index. Now I process it and I add more data to it so we can see what's going on. Finally, I return the response. Now we can try it real quick. Let's see. So
Can you bump that font 2 or 3 times?
Yeah. Bigger.
That's better.
Thank you.
So let's look at, let's see. So we have, let's see, let's see. So we, let's see. So we, 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 so we'll just kind of do, look up Gutenberg. That's the index full of books. Then we'll, let's say, we're going to use this one. I know this one works pretty well, so I'll use that first. Find articles by Lincoln that contain Gettysburg or something like that. So I want to do kind of a fuzzy search, but the user may not know how to do that. So I just say, I just kind of vaguely say that kind of thing. And I'm using GPT 3.5 Turbo. GPT-4 does much, it nails these queries all the time. GPT 3.5 less so, but it can do it too. That's pretty good too. Llama, it's not so great, but it's a much smaller model, and you know that's how it is, I guess. These things get better with scale. Let's execute it. So I found Lincoln's Gettysburg address by Lincoln, contains Gettysburg in it. Here's the query it made. You see the query is pretty complicated. So like Arthur Lincoln, content Gettysburg, like bullshit. Doing all this fuzziness is making a pretty complicated search query from this thing right there. Then I also say for diagnostic purposes, I show what the system message was. Not really readable though. So let's go back. We would try a different one though, because like I said, it does terrible sometimes. Let's change. What should we search for? I only have like 100 books from Gettysburg, but you guys have any recommendations? I know. Well, actually, let's do articles. I don't think this one's in the example database. Show me how many. Show me.
How many angels fit on the head of a pin?
Well, we can try that, see what it does, but that's a good question. I don't think this. That's a good one. I don't know what it's going to do.
Hey, if it comes up with the answer tonight, a lot of philosophers over the centuries will be happy.
Well, you must remember though, it's only generating the ElasticSearch JSON query. So if it may do a good job with the query, but I'm sure the ElasticSearch database doesn't have that information in it. So let's see what it does. I'm kind of curious. So for this question, okay, well, that's not very. It didn't know what to do with it apparently. It said, okay, given what the article looks, the database looks like, I have no idea what to do with this thing. So I'm just gonna make it the title and match it. And it does like it's not just using matching, it's using like BM25, using information retrieval matching mechanism. So it doesn't require this exact phrase, but it's finding documents that contain these words the most. Like maybe it contains angels, maybe the blockchain contains the word angel somewhere. I doubt it though, but and these are the articles in return for whatever reason. Hey, this one seems relevant. Exploring the universe. But that's what it did. Let's go to back to the code. Okay, so actually, I want to show how the small models don't do good, don't do very well. Let's just use Llama 13, Llama 2, 13V. And then I want to also use the local host. Let's see how, let's do a more interesting, a more easy query this time. Show me articles by What's this one? I think this one doesn't do well with this one, so I'll do that one. I think it bombs this question for whatever reason, so. That's not good. Apparently it's doing a large request. Oh, let me see what happened there. Yeah, I think it didn't even construct valid JSON. So it just totally bombed. It didn't even do, I think that's what happened. I'm not gonna read that though.
Hey, Alex.
Yeah,
This is great, by the way. Thank you very much. I was trying to follow along, and I was wondering where are we providing the context of the library of these books? Like I was seeing directly where you're sending sort of the bootstrap statement to OpenAI and the actual prompt, but then where is the context being provided?
the context is, so the system message contains the context, and the system message contains it, and the user query. The system message contains the information about the search index. So when you do a search on this index, that's a database, Elasticsearch knows how to retrieve information about that database, like the structure of it, what fields it has in it, the type of those fields. It can also have metadata. I didn't use metadata, but it will populate the context with information about that. And then the hope is that the language model itself will see all that, the structure of the database, infer what it's for, what kind of, and then it'll say, okay, given this, when a user asks this natural query, a proper JSON query should include these keywords. It should include these fields. Like if it's like choose an author, like if it's say find authors whose name starts with Ben or whatever, it's going to do a search on the author field, but it can do much more complicated things.
So it's just the system message is just the metadata.
Yeah,
it's not the actual publications themselves.
No. I mean, you can do that, but no, this is very efficient. I just wanted to use Elasticsearch to do a quick search on the database, but I wanted to use the large language model just to map natural language to the right kind of queries.
So it's basically just a translation, right? Like
Yeah.
you're typing in natural language and you're using OpenAI to translate that into an Elasticsearch query, which then you're sending separately to Elasticsearch running on your laptop or somewhere. And really that part of it has nothing to do with the AI, right? Once the AI generates the query, then you're just sending that to Elasticsearch.
Yep, you nailed it.
Understood. Thank you.
You want me any more? Well, also one other thing I guess I should show you, because these small models are doing so bad at this task. That's actually the first time it failed at making JSON though. Maybe there's a bug in my code, but usually it made valid JSON, even Llama 2, 7B, even Tiny Llama. It was making valid JSON, but it just wasn't making a good query. So to combat that, I thought, well, maybe if I feed in this context window, these small models, good examples of what a query might look like, maybe we'll do better. So I asked ChatGPT 4.0, given this database and this query, what's a good mapping? What's a good way to? Now I did that because obviously I can't ask GPT-4 each time. If I did that, I may as well just use GPT-4. But I wanted to provide the small models with context about how to construct good queries, and maybe it can generalize from there on its own about using in-context learning. So okay, I kind of see the pattern. Here's what you should do. and it's a pattern based on the existing index. You know, this index has this kind of stuff in it. And the natural language query is going to be for that index. And I thought, maybe that's going to, maybe a few examples will tell the small model a lot of rich information about how to construct these queries. Let's try it though. But let's first look at the examples. So here's, I hadn't had any time to make a proper database. So my database is just a dictionary. But obviously you can expand this and make it more sophisticated. So I have, here's an example, here's a Gutenberg index, and I have an example of a natural language query. So show me books, that one query we did. And then it's okay, here's what the query looks like. For articles, find out about quantum computing. Here's what what that looks like. Number of articles by author. But you can imagine having a bunch of these things, and you can maybe provide 5 examples or 3 or whatever is good for that model. Because sometimes they can easily get overwhelmed by it.
Do you vectorize those before you send them in, or do you just send them as text?
Yeah, listen as a text. That'd be the next step. Let me actually show you. Yeah, so I kind of explain. So now we're here teaching the small models. So we feed examples in, yada yada. Okay, so my finding was that they don't do very good at it, even with examples. And like maybe is this polluting the context window? They just didn't have enough relevant examples. And these queries are pretty, they map to pretty complicated objects. These JSON objects weren't very straightforward a lot of times. And I mean, it didn't do bad. Usually it produced valid JSON that can be enforced too, but this wasn't the best. You can imagine how I can do it much easier or much better. So I thought, well, okay, let's use what you said, retrieval-augmented generation. Maybe the smaller models need to be fed with more relevant examples. So we can use RAG to find examples that are relevant for that search query. Like, so user looks for a certain query, has a certain natural language query, and we can use RAG to retrieve other queries that were like that in the past for that index, and then feed those as examples into the context window of the small language model and see how it does there. I haven't did this yet, but my guess is this would improve it even more, because if you have it, get as many examples as you can from GPT-4 over time. Maybe you sample from GPT-4 every now and then, and over time it just learns to do it. It'll learn to do it better and better for the small models too, because it'll have a bigger and bigger database of this vector database. And another option is to fine tune it. You can see my GitHub for this. This is probably one of the best ways to train them, because they are pretty small models. And if you can just train them in the weights, retrain their neural network, then that's probably a lot better. And you can probably fine tune them for that task. And it's easy to, in this case, it's very easy to get the data you need. You can just generate it either with GPT-4 or even synthetically, or using the algorithms. But in my case, I would just sample from GPT-4 3.5, kind of as an expert trainer to get the raw data for training, for fine tuning, and then let it do it. Okay, so you guys want to see an example of how it incorporates examples into its context?
Sure.
And we're going to use examples, true. And we're using the small model again. think I must have a bug somewhere because I wasn't doing this before. I did update a Python package, and ElasticSearch complained about it. But then again, it was working for GPT 3.5. I don't know. Anyway, the main thing I want to look at is the response. So let's ignore this. Here's the example, including in it. You are world class, natural language to same thing. Now here's an example. Now here's why I retrieve an example.
Again,
Yep, and so
again, I hate to suggest this, but can you up the font size again?
oh
please?
yeah.
Maybe even 1 or 2 more clicks.
Oh,
Yeah, Gary's got a teeny tiny screen over here.
is it Control Enter or plus?
Control plus.
Okay, there.
There you go. There you go.
There we go.
I do Control Shift. I don't know why.
There we
So find articles about. Okay, so here's an example of NLQ and this corresponding Elastic query for this index articles. So it shows the natural language query. And it shows the JSON query that's an example for it. And then the hope is that when you feed this into its context, it can learn how to do a better job itself at generating these things. So with the small models, they didn't do very well at this, not even with those examples. But we talked briefly about how it may be improved using the vector stores or fine tuning. So that'll be future work. I've already started fine tuning them. I have the data collected. I actually sampled GPT like 100 times. I'm a cheapskate. I just did it in chat window, and then from that I actually then used a local model, but Llama, like the next biggest one, and it did okay at generating more examples. And then my intention is to use all those examples to fine tune like Tiny Llama, like a very small model that can just run lightning fast. If you have like the Tiny Llama, I'll show you how fast it is. I'm sure you guys know. It's loading the first time. That's the first time. It takes a while, but yeah, but it can generate. I mean, it's not always the best text, but it can generate it very quickly. And if you fine tune it, it may be good enough. So then you can put these things at all kinds of endpoints, like on APIs and phones, whatever, and then have these things running at lightning speed. You know? And it may also be good for large language models to use, like to outsource them for trivial tasks, or for exploring all kinds of possibilities. Like a lot of times it doesn't need good outputs, it just needs a lot of different outputs to sample from and explore with. So that's kind of my thoughts on that. And I think that's it. Let me see where I'm at with my talk. So yeah, that's it. Any discussions, or you want to see anything else? Like you want to see AutoGen or anything? Although it is kind of late. I didn't think of. I think maybe I'll just we'll just maybe have some final questions and discuss those points.
get them open. Yeah.
Yeah.
Yeah. Yeah, wow, Alex, it's really a great review of a broad area there. So yeah, that's kind of neat. Certainly, if anybody has any questions, kind of here, now's a good time to wrap it up. And Alex, I meant to ask earlier. My fault. I should have inquired earlier. Is your last name pronounced Towell or Towel or Towel?
Towel, the second.
And I wasn't. I was just setting down at the beginning tonight, and I neglected to do an introduction to Alex. Alex recently got his second master's degree from SIU Edwardsville. So he's both has a master's in comp sci and also in math/statistics. And he's obviously been applying it very well to the field of artificial intelligence. And we've got a real tour de force here tonight. So any questions? Well, first off, any questions specifically for tonight's talk? Or comments, suggestions?
I've got kind of a question.
Yes, Steve.
Back when I worked at Boeing back in the early 90s, we were experimenting around with neural nets to do some things. And we would train them on some data sets, training sets, I guess. And they had, certain parameters. They went from, the various parameters went from, one end to the other. And we got networks that did a really good job of answering your questions as long as you stayed within the boundaries of the training sets.
Yeah.
If you went outside that boundary, the further you got outside that boundary, it was just no way to guess what it was going to answer. So wherever you were going to use this thing, you had to make very carefully sure that your training set encompassed everything that you could ask it, or that you would ask it, I guess would be the proper way to say it. Has anybody, I've been completely away from this subject since about 1996. And so I have no idea. Has anybody, has any of that changed since then? Can they operate outside the boundaries of their training sets now? I'm just curious because I've been away from it, for so many years. I just have no idea what the current state of the art is. No idea at all.
Does anyone want to take that?
Yeah, anybody.
There was one that like taught itself Hindi or something. It did it on the fly. There's a couple write-ups about they queried it, and it in about some book or something in the book's that wasn't necessarily, the title wasn't in English, and it came back and with an answer, and they were all perplexed because the book, it didn't have an English translation, and they looked at it and it turns out that I think they queried it even further, of like to say reference something in this book or something like that, and then it gave the answer, and then it referenced Hindi language that it didn't know, that it wasn't shown. I don't know. I don't think it was Chat GPT. I think it might have been a local model. I'm not sure exactly, but there are a few write-ups about that.
Could you, if you can find one of those write-ups, could you post it on SLUUG?
Yeah. Let me see
I'd love
here.
to read some of that.
I could show something that I think might answer the question in an interesting way, maybe.
Please do.
All right, I'm gonna share my screen real quick. So hopefully you can see it.
Yeah.
Yeah, we can see it.
Alrighty. So I'm gonna run Llama 2 locally on my local computer, and I'm gonna ask it what is the St. Louis Linux Users Group? And it knows about us. It knows what we do, and I guess it's got scraped our website here, so it knows all about us. And then I can ask it something like this. So I say, here's an abstract from an upcoming presentation for the next St. Louis Linux User Group. Please summarize this abstract into an enthusiastic tweet. Okay. And then I'm going to paste in the abstract and send that. And this is the abstract from the talk I gave a few weeks ago about system D timers. And here it generated like what looks like probably a bit too long for a tweet, but pretty close. And Sean will reveal 3 game-changing features, blah, blah, blah. And it's got like emojis and it's got hashtags. And so I think this is kind of an interesting maybe use case for how we could use these local language models as a user group here if we wanted to. And we could, you know, maybe do some other things here, like we could ask it like, hey, what are the main technologies discussed in this abstract? And then it could, you know, it does a decent job here where it's like, hey, system D timers, cron tabs, shell code, you know, some of this isn't the greatest, but you know, it's better than having to like type all this out yourself or think about it yourself. And then you can ask follow-up questions like, hey, what topics would be good to follow up after this presentation? And it could maybe give some suggestions like, oh, if people like this one, here's some other type of topics that that might be good for future talks, like integration with other tools or technologies like Ansible and Puppet. You know, I think that's right in line with system D timers and stuff like that. And so, you know, you're saying outside of, or, you know, you asked the question about outside of its data set. Well, I think that these models were trained on basically the whole internet. So it's kind of, I think it's kind of hard to answer like what's outside of the data set, but you know, anyway, I think that we could use this as a user group to kind of make things easier or, you know, do some of this kind of stuff and really use this to our advantage if we put a little work into it. So anyway, just some ideas I had that I wanted to share. Thanks for indulging me.
I have put the article link to, it was Google AI teaching itself Bengali.
Wow.
Okay.
Yeah, really.
I put that in the group chat.
My
Yeah,
Zoom is acting a little weird.
That is. I don't know what's going on there.
It frequently acts weird.
TBS News.
yeah, that one. Because yeah.
No.
Hey, Alex, with your master's in computer science and now statistics and your familiarity with making local models or trying to train them, I'm surprised. Have you thought about getting into trading in the future based on a model? I've been perusing the idea and I have not nearly the knowledge base you do. So I'm interested in your thoughts on training a model that would do a bit of trend analysis, market sentiment, because it can ping the internet. It can get the sentiment of the Yahoo News. It can read it all faster than we can. Like just the example given a second ago, he showed it going through just the previous presentation and thinking critically about that. So it seems well within the realm of possibility to run locally and do something like that.
No, kind of outside my wheelhouse, but now I'm just trying to get a job with like Meta or OpenAI, but of course they're highly competitive. So yeah, I haven't really thought about doing that. But yeah, you know, I mean, it seems interesting.
I mean, because every exchange has APIs and API calls that can be done. There's even MetaTrader 4 and 5 that there are exchanges specifically for interpreting code and PineScript. And I feel like you might be surprised how far you'd make it if you put a weekend into it.
Yeah, I'll think about it. Thank you.
Yeah, I see. I found your article here. Interesting.
And you never know how truthful they're being. You know, it's hard for me to believe that Google scraped the whole internet and didn't run into Bengali before. So I don't, but it has been claimed. So I'm not, yeah.
They scraped the whole internet.
Well, I'm assuming that's what Google did. I mean, that's their, yeah, I'm assuming that's what they had it trained
I
on.
find that a
So,
little hard to believe, but
I mean, that's what their search engine does to an extent.
yeah.
So yeah, I don't know. It's hard for me to believe they
That's
did it
just
without
looking,
it
the
knowing of
search engine's just
Bengali.
looking for keywords and key phrases, I think. That's interesting.
There was an Aspen Institute webinar recently, and one of the guys that works at like the NSA or the Department of Defense, I can't think of his name. He said it only takes 45 minutes to scrape through the whole internet. I don't know what he was using, but he says it's a 45-minute thing and it's done.
Ooh, wow.
No kidding.
Yeah.
I'm not sure I believe that.
And then he said, it's just a series of tubes.
Yeah, no, I mean he worked for a DoD or White House. I mean it was a very prestigious cybersecurity conference. Yeah. I was surprised when he said it too, but he rattled it off like it was not a big deal. So I don't know. I don't know how long it does take Google to index everything or even Shodan or any of the.
I don't think you could ping every computer on the internet in 45 minutes.
No, I agree. It's yeah.
You know how many? I can't
Let
imagine
alone
how many
the
million routes.
bandwidth you would need going in and out to make
Yeah.
all that. The calls, let alone the indexing of said info that came back.
Yeah, that sounds to me like I'm not sure I believe that guy. But hey, ask it what's the biggest problem with converting 30% of our cars to battery electric? I'm kind of curious how it would answer that. Because that's all over the internet.
And that's kind of another reason why AI is super relevant, is because there's so much SEO around positives and negatives of both. It's hard to get. I find myself relying on AI potentially to give me the news story that's not so just drowned out in all the Google links or whatever, because there's so much just SEO out there that it kind of ruins Google search in a sense, or whatever search engine you're using to try and get info.
What do you mean SEO?
Search engine optimization. It's what people put in like websites and stuff, so they rank higher on the Google like page or whatever. And it's the reason why when you search things now, it's not nearly, it's honestly like Google search has been getting worse because SEO is built into so many web development platforms that they make so much noise and clutter that it was better to get info directly from AI, who had it can read through the links that, oh, that's the same, these are different, and it aggregates the info more efficiently instead of me having to scroll through 2 to 5 of the first pages to find something that's different or an actual first-hand account of a news story.
It's better than any of us can.
Yeah.
But how would I pose that question about electric cars to one of these AI engines?
You got to start with you are a world-class climatologist or something like that. It's weird how like these AIs are so good at like impersonation. That's what I've always found weird. Like even the system prompt that Alex was showing us started off with "You are a world class such and such." It's like you gotta get the AI to role play if you want a good answer.
Yeah, well, I mean, the reason I posed that question is because I already know the answer. It's not super simple, but
I've
not that
found
complicated, really.
getting it to sometimes the good prompting helps, but or is a good way, but I've kind of found good results with just jogging its memory beforehand. Being like, well, tell me what you know about the climate. Tell me what you know about car production. Tell me what you know about emissions. And I don't know why I get way better answers on stuff like that. And then I kindly slowly lead it into, okay, well then with everything that that you know, what is your thoughts about this? And then I can get a way more elaborate, coherent conversation, like response, instead of just a generic copy
Yeah,
of some other article it found.
it's not, it seems like you're bringing some of that knowledge to the surface or bringing it higher up so it
Actually, I think it
sees better.
sends the whole chat history each time. So every
I'm sorry?
time you send a new chat response, I think it includes all the previous chat history, right? Because it's not actually, it's my understanding that all your OpenAI is a REST-based system, so it's stateless between the calls. So if you ask it, hey, summarize this, and then you ask it in another call, so what was the main character's name? The only way that it knows like the context of your previous question was if it sends the entire history again. So by you kind of doing those pre-prompts, when you do the final question or whatever, it's probably sending all of that, both the question and the responses every time to, just building and building and building on that context.
That almost sounds like a bandwidth and a memory problem.
But it stays locally on their servers. It only, I mean, it's honestly because it's not sending the whole chat to you. It's only sending its more recent response. But that, I mean, it's possible because I've even noticed it when I do trading stuff, or let's say I'm having it write me cover letters, or helping me build a resume, or trying to just, what are the top known books for financial trading or options trading, or what are the top known books for cover letters or information pertaining to it. And it seems to, yeah, and it would make sense that it's sending the whole thing again. I'm surprised it doesn't increase chances of hallucination, but I've wondered why it gets better. So it makes sense. Yeah.
Hey, Steve,
Sir,
what's your question? I can ask ChatGPT and share my screen.
oh, okay. Well, let's see. What's the biggest problem with converting 30% of all automobiles to battery electric? You type like I do.
Let me know when you're done reading.
All right, go ahead. I'm not a fast reader anymore. Okay, there more? Second line under number 4 is not correct.
This one?
Yeah. I've never really seen a case where the total cost of ownership was lower.
Depends on the price of electric, probably.
Well, yeah, but there's a lot more to it. Those suckers are heavy,
Or
and
if
the
you ever,
insurance companies
if
don't
you get
want
a
to
fender bender, yeah.
pump it, you have to replace a $20,000 battery ad nauseum, ad infinitum. Yeah. I don't know. It seems like it just gave me a list of all the possible problems. There's a few hard ones in there. Like right now, there's not enough rare earth elements to make all the batteries. There's not enough power in our grid to charge them. It's just not there. It's not that it faces problems. It's just you can't do it as fast as the government wants you to. Now, I have no doubt that in 100 years they'll all be electric, but
That's actually a solid question. Ask it if there's enough electricity in the grid for all of us to drive electric cars.
yeah.
Ask it if humans will be here in 100 years.
That's a better question.
Phrase it more accurately. Is it? Oh well. You should have asked her. Is there enough generating capacity?
By the way, I have it doing these long-winded outputs because I have it thinking like step by step. I'll show you what my core principles. I have it doing all this stuff. So it produces long outputs, but it's good for like math research and stuff.
Okay.
Just like step by step reasoning, and it's pretty long context when pretty long prompts, but and I always tweak it, but it seems to work pretty well for a lot of any kind of step by step thinking. But yeah, it also produces very long prompts, and so sometimes you got to tweak it.
So you said you use this to help you write Python, and I know I've heard that ChatGPT actually can run Python code, and then like it can actually run it, and I guess if there's like a compiler error, it will know not to show you that one or something.
This will probably make it write a prime number algorithm, and I'll put it. So now it's writing code to solve the problem I asked it. It's going to run that code too. And look at the output, then it'll tell me. And that's probably correct. This code looks correct. This prime is, I mean, this is correct. So, of course, it's seeing plenty of data for prime number for prime number finding algorithms. So it's not that amazing. It's pretty good at any kind of boilerplate code. It doesn't do too well when the code gets long or is kind of new or novel, but it's getting better. And the main thing is it can use anything that's been like boilerplate code, solve problems that it knows that are published, and even knows how to combine existing solutions in trivial ways, sometimes in novel ways, but you can rely upon it to generate code and then output it, incorporate that into his answers, and give you a response that's pretty reasonable. Like he's able to answer this question. And of course, this can be hidden normally. So you don't have to even see it. All you see is this. 2000th prime number is this.
That's interesting. So it analyzed your prompt, realized the best way to give you the correct answer would be to write some Python code and then run it.
Yeah, it even made comments to itself. To find the 2000th prime number, we can use a simple prime finding algorithm.
It does that I find it writing Python for a lot of things that I don't
Yeah.
even ask for. I've done document OCR and it writes
Yeah.
Python to run a Python program. And yeah, it actually, I find it defaulting into Python quite a bit.
Yeah, it loves Python. And Python is being able to program is a very powerful tool to have available to you. You know, a lot of times, if I want to do something trivial, I don't want to install the application, I'll just tell ChatGPT, write a program to convert this to PNG, or some stupid little program that I don't want to have to download and install. You can just ask ChatGPT to write the program for you and then run it.
That's awesome.
Yeah, you can imagine in the future, like more and more of this, like most applications will just be one-off things that ChatGPT writes for you, runs it, then you throw it away.
You just made me think of something. Can it write Pong?
Right, Palm, what's that?
Like Pong, the old game, the beep boop
Oh,
8-bit game.
That would be interesting.
it's even, well, this might be, it's even installing the library. This may be kind of easy for it because it's using nice library to do it, but yeah.
That's really interesting.
Oh yeah, I mean, it's very
This
powerful.
might take a while. Could you interrupt it or stop it?
Yeah, I'm gonna stop it. Or you want, or you
No,
want,
no, I don't want you to stop. I just wonder if you can.
yeah, you right there, just the stop button. I'm always stopping that because they shut up and just tell me what I want to know, but we try to run it.
Can you
Sure.
run it? Yeah.
Yeah,
Oh
okay.
yeah, please do.
Oh, okay, just copy the code out.
Yeah. Good enough.
Ding, ding.
I can't type.
You type better than me, so it's fine.
So in this case, I need to install this module. So it didn't do it right, but you could actually feed this back into it. We'll try. Oh, this is okay. This is trying to load the driver. I'm not sure I have that.
See if it can run within the instance of ChatGPT. Tell ChatGPT just to like put in the command to run in ChatGPT and see if it'll.
It'll run like things that don't produce like graphic outputs, but that one if I won't run, we can try. But first, I'm gonna produce the outputs that it gave me, the error message. See what it says about it. Just take the whole thing and copy and paste it. I'm gonna stop it until it. We'll just have it produce a simple ASCII game. It'd be kind of neat if I got it right. A lot of code.
Next, I gotta ask it to use assembly. No, I'm kidding.
It will.
72 lines.
What?
Oh yeah, here we go.
Let's just run it as root.
Yeah.
Why not? I don't care.
And they wonder how AI is going to take over.
Well, I have it running on my computer sometimes. This program called Open Interpreter. It'll just you'll type like ls. It'll say, "Oh, I think you're," or show me like type, "Show me my files." Say, "I think you want to run ls. Shall I run it?" So sure, you know, you can have it more or less controlling your computer. Not sure why I stand that. I probably didn't saw it.
It's pip. It's pip, right? Not apt, but you installed it as your user with pip, right? And then you're running
Yeah.
the script as root. So
Yeah,
maybe you need to install it globally, but maybe that's not worth it for this little game. I don't know.
yeah. I think you're right. No, I'm not gonna do it.
It's all good. That's still impressive though that it was, because now in like in you know how long before it is able to do like Ridge Racer, and then 5 more years it'll. I mean, yeah.
Yeah.
That's what I. Yeah, that's what this is my my
Well, look,
conspiracy theory. Oh, go ahead. Sorry.
But it even says, "Please note the keyboard module may require." So even okay, yeah, it told me to okay. It said to do that. Okay, I don't know what.
Oh, so you must be root to use this library.
Huh.
So if you just run it as sudo, I could be wrong.
Yeah, it even mentions it.
Yeah, I think you need to do like pip install global, right? Yeah.
But it totally, yeah, and okay, so that's the 8-bit era. You know, if it can nail Mario, and then it's the 16-bit
Yep.
era, then the 32-bit. I wonder how long that is away.
I can't wait, man, because I think VR is so cool, but the problem is like creating those 3D environments is so labor intensive, right? Like it's just so hard to create really good 3D environments by hand. It takes forever. But if we could get AI to generate really, really good 3D environments, we could have like the most immersive VR games, I think.
some of that
It'd be a lot cheaper to develop
does
VR games, I think.
exist because like there's procedural generation, and I know you can play No Man's Sky in VR. So it kind of is a thing. That's also why I asked earlier on if it was making assets or if these just videos, because it's played with a little bit of AI generating assets that could then be used procedurally to populate a whole world.
One last time, then we're done with this pawn game.
Oh man, you spelled the file right. We're gonna get it this time. I
Oh,
feel it.
no. So I can't type though.
Hi.
Ghost.
It's even playing pawn.
Oh, dude. It did it.
It's a bit wonky, but it's doing it, kind of.
So are you up and downing, or is it up and downing
But
too?
it's playing a bit. It's playing itself. So I can't
Playing
even.
itself.
This is like the war game. The only winning move is not to play.
Do you want to play thermonuclear war?
I knew that was coming. I knew that.
Looks like the guy on the right is winning big time, though. Also does some weird things. That means it's not perfect, but it's more than you might expect, though.
More than I could do
Yeah, really.
in like a 10-minute span. It's yeah.
Well, yeah, it wrote like 4 different Pong games. Some of them didn't work for my system because it required certain libraries. And
What about Towers of Hanoi?
yeah, it can do that one pretty easily, I'm sure, because it's such a solved problem. But anyway, I am pooped.
Good
Alex,
presentation.
thank you very,
Thank
very
you.
much.
Yeah.
It's been a fascinating evening. We appreciate it.
Well, thanks for attending. I know I'm kind of long-winded at times.
Covered a lot of good material. So
Yeah.
But thanks for coming. I appreciate it. And thanks for your questions.
All right. You want to bookend it, Gary?
and this has been the
Hey, don't forget, anybody's here to tell them about the ballots are available on the main page.
Oh, shit. I almost forgot about that.
yes, this is election month. Anybody who attended 2 meetings, any of our meetings in the year 2023, if you attended 2 meetings, you're qualified to vote. We're voting for the board of directors. And let's see.
Where's the link, Stan?
On each web page, there's a paragraph that has the ballot link there. It's www.slug.org/ballot2024.pdf.
Okay. Yep.
Go ahead, finish the book then.
Let's see. This is the
Send your ballot in.
yes, send your ballot in. You can print it and send it in by U.S. mail, or you can do the PDF and email it in. I've got to sneeze. Excuse me.
And thanks to Stan, it works interactively. I have never seen anything like that.
I wasn't sure it was working right. Anyway, vote early, vote often.
Looks like it to me.
And that's why we have the ballots timestamp. So we take whatever the most recent ballot somebody sent in. So, all right. This was Thursday, the 22nd of February, 2024. It's the St. Louis Linux User Group, St. Louis LUUG. Alex Towell was our speaker this evening, and he was telling us all about large language models, LLMs, in Linux. And so we really appreciate his efforts tonight. And thank you all for coming. Good evening.